Throughout the years, scientists have made some discoveries that seem to hint at the existence of extraterrestrial life. But do they really? Let's find out. In 1976, NASA's Viking Mars landers detected chemical signatures that could be a sign of extraterrestrial life. During one of the experiments, Martian soil was mixed with special nutrients and then tested for the production of methane gas, and the test's result was positive. In other words, something in the soil was metabolizing these nutrients and producing the gas. Unfortunately, other experiments conducted on board the landers didn't show any evidence of life. It caused NASA to declare the result a false positive. And still, some scientists keep standing by the finding, arguing that the experiments on board were ill-equipped to look for a key indicator of life, organic molecules. In 1977, an Ohio State University radio telescope detected a bizarre pulse of radiation coming from someplace near the Sagittarius constellation. It lasted 37 seconds and was so unexpected that the astronomer who was monitoring the data at that moment scribbled, "Wow," on the telescope's printout. The thing is that the radio frequency of the signal is internationally banned on Earth. The signal could be the result of a supermassive astronomical event, or it could be sent by some kind of intelligent life with immensely powerful transmitters. So far, this mystery has remained unexplained. In 1996, NASA scientists announced that they had found something that could be microbes in a potato-shaped chunk of Martian rock. The meteorite might have been blasted off the surface of Mars in a collision. It had been wandering the solar system for about 15 million years before it fell in Antarctica. Analyses showed that the meteorite contained some organic molecules and tiny particles of the mineral called magnetite. It's sometimes found in bacteria living on our planet. NASA researchers used an electron microscope and announced that they had spotted nanobacteria. But since that time, this evidence has been called into question a few times. Some experts say that the particles of magnitude are not really similar to those found on our planet, and Earth's contaminants are likely to be the source of organic molecules. Jupiter's moon Europa has a bizarre red tinge. Some of the theories explaining this phenomenon have suggested the reason is frozen bits of bacteria, which are also responsible for the mysterious infrared signal the moon gives off. But this theory hasn't been proven yet. The existence of life in Venus's clouds might explain curious anomalies in the composition of the planet's atmosphere. Solar radiation and lightning are supposed to generate tons of carbon monoxide on Venus, but in reality, this gas is rare, as if something is removing it. Another weird thing is the presence of both hydrogen sulfide and sulfur dioxide in the atmosphere. Usually, these two readily react together. That's why it's rare to find them coexisting. The only explanation can be that some process keeps churning them out. But probably the most mysterious is the presence of carbonyl sulfide. The thing is, on Earth, it's only produced by microbes and not by some inorganic process. Some experts believe that microbes might be living in the atmosphere of Venus. The surface of the planet, scorching hot and acidic, isn't very suitable for the development of life, but up in the atmosphere it's moist and hospitable, with a pressure similar to Earth and pleasant temperatures. But again, we haven't received any solid proof yet. In 2003, scientists discussed the possibility that the traces of sulfur on Jupiter's moon Europa could be the waste products of colonies of underground bacteria. The compounds were first discovered by the Galileo space probe, which also found some evidence of a volcanically warmed ocean beneath the icy crust of the moon. The sulfur signatures look similar to the waste products of bacteria living in the surface ice covering lakes in Antarctica on Earth. But other scientists rejected the idea. They argued that the sulfur could have come from the neighboring moon. Io there, it's found in abundance.
If you could track the line of evolution and go back an exceptionally long time ago, you'd see some weird creatures called Ediacarans. It seems like these little fellas made of tubes showed up 579 million years ago. They thrived at the bottom of the ocean for about 37 million years, chilling and minding their own business. It continued until they disappeared, or better yet, turned into faint marks we now only know from the sandstone fossil record. The world started to change for these ancient creatures somewhere around 541 million years ago, when a lot of new life forms came into being. Some new creatures began to evolve, and it's possible they might have replaced our friends. They might have changed the environment in ways that made it hard for these poor fellas to survive. Why does this even matter that much? It was the first time when a complex life form went extinct because of other living things. Usually, when you hear about lots of creatures vanishing from the face of the Earth, it's due to something like a giant volcanic eruption poisoning the oceans, or a big space rock slamming into our planet. For example, 440 million years ago, a big change in the planet's climate happened. The water in the oceans became colder, and it wiped away a lot of ocean life. The southern part of a big landmass called Gondwana ended up covered with ice quickly. This made a lot of Earth's water turn into ice, which, again, caused the sea levels to drop. Creatures from that time were struggling to find food. Plus, they didn't have homes where they could evolve, live, and reproduce. Then there was this interesting period called the Age of Fishes, when a wide variety of different sea creatures appeared on Earth. Even though some animals were starting to live on land, most of the action and fun was still in the oceans, at least until the moment when trees and plants ruined the party. Their roots started growing on dry land, and it transformed the world, turning rubble and rock into soil. This was fun for land animals, but it gave all those fellas in the ocean depths a lot to worry about. The soil, rich in nutrients, got into the oceans, which made a lot of algae grow in the water. These blooms eventually caused enormous dead zones, where algae took away oxygen from the water. So lots of marine animals that were simply fine living their peaceful lives in the ocean couldn't breathe there anymore. Plus, they didn't have enough food to survive. Or we can talk about the biggest extinction event called the Great Dying, 253 million years ago, when almost 90% of all species on Earth vanished, including many land creatures such as insects, reptiles, and amphibians. This happened because of insanely strong volcanic eruptions. When you see what happened in the past during these extinction events, you can understand better why the case of Edacarians is so intriguing. Researchers haven't found any evidence that low oxygen levels or some other troubles that might have happened in their environment could have caused them to disappear. Also, they've agreed that conditions weren't that bad since the creature's fossils remain intact. They look for answers in southern Namibia, studying rocks that contain fossils from the time when ancient creatures vanished and new ones came to the scene. Researchers found many traces of these new ones left behind. Modern animals are like architects of their environment. They change things around them, dig into the ground, and eat one another. But if they caused ancient creatures to disappear, the remains of those species had to show some signs of struggling, something the fossils from Namibia indicated. Traces were similar to predatory sea anemones. Well, you know what I'm trying to say. How did tiny, simple cells even turn into such complex organisms anyway? Throughout time, they got bigger and ended up with nuclei and mitochondria, parts that help cells work, but it's still not completely clear what really happened here. The most accepted theory is that mitochondria, which are like the powerhouse of the cell, came from a kind of bacteria that got inside another bigger cell. This bigger cell started to change over time, developing more parts, like the nucleus. This way, a cell became stronger and more complex. That sounds cool, but we can't be sure of this. One of the problems with this idea is that we don't see cells in between the simple and complex stages. There's also a new theory that says that the first step toward complex forms of life involved a bacterial cell that formed bumps on its surface. These bumps trapped similar bacteria, which then helped the cell get bigger. As it grew, the bumps turned into parts, and some of these parts later turned out to be useful, such as endoplasmic reticulum, the outer nucleus membrane. More and more parts started developing, which meant increasingly complex forms of life. And the most complex known creature that we ended up with is this tiny transparent water flea. It has 31,000 genes, which is 25% more than what humans have. This water flea is especially interesting because it can transform its shape when things get tough. It can grow spines, helmets, or even teeth depending on its surroundings, and this might be because it has so many genes. Scientists copied its genes, and instead of staying the same, they quickly changed their roles to adjust to the environment. Researchers believe the copied genes would stay the same and only change later, so this was a bit of a surprise. And this interesting creature even has some genes like ours. This may help us understand our own kind better. For instance, how humans react to different threats in the environment, and how we can improve things that negatively affect our health. Or imagine if we could grow some of those cool additional organs like this water flea. The first complex forms of life are older than we thought. 1.6 billion years ago, there was a happy community of small, bright red things that looked like plants. It was flitting around in a shallow pool of ancient waters and eventually ended up trapped in rocks and preserved till the end of time. A few years ago, scientists from Sweden found these fossils in India and concluded that they could be red algae. Using a special method, they carefully extracted them from the rock and discovered two types of red algae, one that looked like a segmented noodle and the other with layers of cells. To understand them better, the researchers made 3D models of them and used radioactive dating to confirm their age. If that's true, they're almost 500 million years older than we previously thought. A very long time ago, our home planet was hot because of all those things slamming into its surface, like asteroids and comets. This made it difficult for life to start there. But about 3.8 billion years ago, these hits slowed down, and life finally appeared on Earth. At first, those were simple life forms, but then more of these space objects hit Earth, and it's possible some of them brought water and other stuff important for life. Some life forms survived these hits and finally had a chance to evolve. However, we still don't have unambiguous evidence of how it all started, so no one is sure if life on Earth appeared just once or multiple times in unusual ways. Our planet had building blocks, which are elements important for the appearance of life, even a long time ago. These blocks could have appeared naturally or might have come from space rocks. As they joined together, they formed more complex things like proteins, fats, and DNA. And maybe this process happened more than once. Someday, we'll find the answers because it will help us understand not only our planet, but the odds of life emerging on other planets too.
The space crew had been getting ready for the launch for over 3 years. The preparations for landing on the strange planet included gathering and studying rock samples in the Grand Canyon, exploring ancient volcano formations in the Nevada National Security Site, and looking into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. To be able to resist microgravity conditions, they learned how to walk obliquely by being strapped and suspended sideways and trying to move along walls. They had to test their limits through intensive diet and sleep regimens to make sure they'd be safe in outer space. It took them 3 days, 3 hours, and 49 minutes to reach the surface of this new world in a place called the Sea of Tranquility. They could have gone for the Ocean of Storms or the Central Bay, but they chose this place to land because it had good visibility and it was relatively smooth and easily reachable with as little propellant as possible. One of the first things they noticed when they got there was that, well, the place kind of smelled. This may sound like the beginning of a science fiction novel, but it's actually the true story about how the Apollo 11 mission landed on the moon on July 20th, 1969. Since then, the moon has had 12 human visitors to this day. We think of it as our neighboring space buddy, but there's still much we don't know about this mysterious satellite. And that should come as no surprise, since the moon is actually always showing us the same face. That is because the Earth and its only permanent natural satellite are in synchronous rotation, which makes us think it's always permanently still. The truth is, it's not in a fixed position, and it is actually moving further and further away from the Earth each year by 1.5 inches. Believe it or not, the Earth and the Moon, although being 238,855 miles apart, deeply influence each other. While the Moon is partially responsible for the tides of the seas and oceans on our planet's surface, our Earth is actually to blame for movement on the Moon. They're called moonquakes, and they last way longer than earthquakes, some of them up to half an hour. It may look perfectly round to us on a warm summer's night, but the Moon is actually oval. The lemon-like shape is caused by the Earth's gravitational pull. Our Moon features more than footprints when it comes to traces of humans. In 1969, American astronauts left many objects on the surface of our satellite, such as 2 golf balls, a drawing by famous artist Andy Warhol, and a message from Queen Elizabeth II herself. One of the last people to walk on the Moon to this day, an astronaut named Eugene Cernan, scribbled his daughter's initials on the Moon's surface in 1972. Since it appears there's no wind or any other type of weather change there, the letters TDC could remain there permanently. It's actually possible to be allergic to the Moon. Harrison Jack Schmitt, an astronaut from the Apollo 17 mission, spent some time in a valley in the Sea of Serenity, then climbed back into the crew's lunar module, but had some moon dust on him. Just as he removed his spacesuit, he got red eyes, sneezing fits, and other allergic reactions that lasted 2 hours. Since it's so close to us, we've established that the Moon has a time zone of its own. We call it the Lunar Standard Time, but it doesn't correspond to time on Earth. To get an equivalent, the explanation is a bit more complex, but in simple terms, a year on the Moon is split up into 12 days, each one about as long as a month on Earth. Each one of these days got its name after a different astronaut who has walked on the Moon. The start date of this calendar coincides with the moment Neil Armstrong walked on the Moon. So, the Lunar Year 1, Day 1, began on July 21st, 1969 at 2:56:15 Universal Time. Since the Moon has a very thin atmosphere, it has some pretty crazy temperatures, both hot and cold. They can go up to 200 degrees Fahrenheit. Over by the Moon's poles, however, the temperature is always at around minus 400 degrees Fahrenheit. Humans have tried to trace the connection between our natural satellite and the Earth for as long as we can remember, coming up with words to explain why the Moon's existence influences us so. In the Middle Ages, scientists and philosophers thought that during a full moon, some people were more likely to experience different health conditions. Because they saw this inexplicable connection to the full moon, people with these symptoms were named lunatics, or at times, literally, moonsick. People are not the only creatures living on Earth that are affected by moon cycles. Dog owners are 28% more likely to take their pet to vet emergency rooms during the full moon. You may think that's the reason why wolves have this preference for howling at a full moon, more so in popular culture. But scientists haven't been able to find any connection between wolf behavior and the lunar cycles, so it might as well just be a myth. The largest known crater in our solar system is also found on our moon, and is called the South Pole Aitken. This giant formation is located on the far side of the moon and measures 1,550 miles in diameter. One of the many things we've yet to fully understand about our satellite is the unusual flashes of light that can sometimes be seen on its surface. Scientists have named these outbursts transient lunar phenomena, or TLP in short, and they have been seen all over the world for centuries. One of the first instances of TLP dates back to 1178, when monks from Canterbury claimed to have seen a flaming torch on the surface of the moon after the sun had set. TLP does not simply mean light flashes. Reports also have detailed other unusual events, such as gas-like mists, reddish, green, blue, or violet colorations, or even the darkening of certain locations on the moon. Is something strange happening with our moon? Is it the beginning, or did we just start noticing it with the newer space study equipment we have nowadays? There are a lot of different theories that scientists have developed trying to piece together what can be causing these events. The unusual flashes on the moon can be caused by anything from meteoric impacts to electrostatic activity. It's difficult to pinpoint the explanation for each event, since most of these episodes are recalled either by a single observer on Earth or from a single location. The fact that there is noticeable seismic activity on the moon can also explain why we can sometimes see unusual flashes of light on the surface of our satellite. When the moon's surface moves, it can cause different light-reflecting gases to erupt, which can explain luminous developments. Some scientists have even suggested that residual geologic activity may also be the cause. This is all the more shocking, given that we've always looked at the moon as a lifeless world. Did you ever notice that our moon can change its color? There are actually many scientific explanations for that. The moon appears to be a brown-tinted gray when you look upon it from outside of the Earth's atmosphere. When gazed upon from the Earth's surface, the moon appears to change color depending on various phenomena. The moon seen near the horizon will most likely be yellow or red-tinted. The rarer, blue-colored moon indicates that you're looking at our satellite through an atmosphere carrying larger dust particles. The moon can even appear purple at times, but what causes this specific hue is still up for debate. The fact that we don't know exactly if or how much water there is on the moon's surface is not the main reason why we aren't already building houses up there. It seems that radiation actually has a lot more to do with it. Recent studies have shown that the moon's surface has a radiation rate 5 to 10 times higher than that you experience on a transatlantic passenger flight. That also means it's 200 times higher than the rate on the Earth's surface. In future lunar explorations, like the Artemis project for example, scientists need to take this into consideration, not to expose the astronauts. Named after Artemis, Apollo's sister, this program aims not only to place astronauts on the lunar surface in the future, but also to build some sort of an establishment there to study the moon in safe conditions. While the project started in 2017, the first planned mission is set for launch in summer 2022, with an estimated duration of 25 days. The space object, with no crew on board, is planned to reach lunar orbit and safely return with sufficient data for the next 4-person mission scheduled for May 2024. Artemis 3, 4, and 5 are expected to be launched in 2025, 2026, and 2027 respectively, each with a planned duration of approximately 30 days.
For centuries, people believed that all swans were white because that was all they had ever seen. They thought it was a universal truth. Then one day, someone discovered a black swan. It was a surprising and unexpected event because it went against what everyone believed. So yeah, the theory is named after this idea of a rare and unpredictable event that goes against our assumptions and expectations. It isn't related to the Darren Aronofsky movie. You know, the one starring Natalie Portman as a committed dancer? Nassim Nicholas Taleb is the person who named this theory. He suggested that these types of super rare and unexpected events are impossible to predict, but they can have a massive impact on individuals, businesses, and societies. The theory was originally used to explain financial markets, but has found its way into various fields. Taleb calls those extremely rare events black swans. Now, these events are so rare that the usual tools of probability and prediction, like the normal distribution, don't really work. They rely on large populations and past data, which we don't have for rare events. So, trying to use statistics based on the past won't help us predict black swans. Let's dive into some examples of past black swan events. The rise of the internet is actually a great example. It's now hard to imagine a time when people couldn't Google their burning questions or watch funny cat videos online. The internet's growth and impact caught many by surprise. It transformed the way we communicate, access information, and even buy fluffy socks without leaving the couch. A digital revolution nobody truly saw coming. Recently, we found an infant black swan on the internet: the emergence of cryptocurrencies. Bitcoin and other cryptocurrencies created new forms of decentralized digital currency and disrupted traditional financial systems. Then we have the invention of smartphones. Picture a world where phones were chunky, had buttons, and only made calls. Suddenly, boom! Smartphones turned everyone into walking wizards with tiny devices in their pockets. From taking selfies to driving with GPS, these pocket-sized marvels changed the game, surprising us all with their incredible capabilities. Here we can also mention the rise of social media. The emergence of platforms like Instagram revolutionized communication, enabling people to connect and share information globally. The creation of the internal combustion engine was a game changer too. Long ago, horses trotted along the streets, leaving a different kind of horsepower behind. But then, ta-da! The internal combustion engine roared to life, propelling cars and transforming transportation forever. Who would have thought that a mechanical contraption could replace our equine friends and pave the way for road trips and drive-thrus? What about black swans related to our bodies, like decoding DNA? Once upon a time, DNA was a mysterious code, like a secret language of life itself. Then, science unraveled its secrets, revealing the blueprint that makes us who we are. This groundbreaking discovery in genetics opened doors to medical advancements and personalized medicine. Imagine you're a scientist working in a lab. One day, you forget to clean up your petri dishes. You know, those plastic or glass things commonly used for growing microorganisms. Then, you leave for a vacation. When you return, you find a happy accident. A mold called penicillin has grown on one of the dishes and exterminated the bacteria around it. That's what happened to Alexander Fleming. This accidental encounter with mold led to the discovery of penicillin. Hello, one of the most important medications in history. At the time, bacterial infections were a major threat to human health. Fleming's chance observation opened the door to a whole new way of fighting infections and revolutionized medicine. Now let's take a peek at Europe in the 14th to 17th centuries. It was like a scene from a historical movie. People are emerging from the Dark Ages, embracing newfound knowledge and experiencing an explosion of creativity. This period is none other than the Renaissance. It's a black swan too, because during that time, there was a tremendous surge in artistic, scientific, and philosophical achievements. Incredible minds like Leonardo da Vinci, Michelangelo, and Galileo were pushing the boundaries of human knowledge. The Renaissance was like a giant wake-up call for Europe, shaking off the cobwebs of the past and embracing a new way of thinking. It was a black swan event because it changed the course of history and ushered in a period of immense progress and innovation. It reminds us that sometimes, out of the blue, a wave of inspiration and brilliance can transform the world. Let's take a step back, or 1,000 steps further, and consider the moon landing. The Apollo 11 moon landing in 1969 was an extraordinary feat of human achievement and a positive black swan event. It showed humanity's potential for exploration and scientific advancement, inspiring generations and pushing the boundaries of what was deemed possible. Not all black swans are good and positive though. When it comes to the stock market, a black swan event is like a super rare market crash that goes way beyond what anyone could expect. We're talking about events that statistically should hardly ever happen. The Great Depression is a classic example of a black swan event. It happened in 1929, but its effects lasted for a long time. The economy was booming with happy days. Then, the stock market crashed and everything went haywire. It was almost impossible to predict, like trying to guess the lottery numbers but on a global scale. The world had never seen such a massive economic meltdown. At its peak, 25% of Americans found themselves without a job. The economy took a nosedive. The US GDP dropped by 30%. Over 9,000 banks waved the white flag and said, "We're out." Oh, and there's something called a gray swan event too. It's not as rare as a black swan, but it's still an outlier. The good news is that gray swans are a bit more predictable than black swans, so we can better prepare for them and take some measures to protect ourselves. Let's play a little thought game. Imagine we're weighing a bunch of people, and one of them happens to be the heaviest person in the world. Even if that person weighs 2,000 pounds, it doesn't really make a big difference in the overall average weight of everyone we weigh. It's like a drop in the bucket. This shows that extreme outliers like this super heavy person don't have a huge impact on the average. Now let's do a similar experiment, but this time with wealth. We gather a group of people, including one billionaire. What if that billionaire's wealth is 99% of the total group's wealth? Unlike the weight example here, the outlier dominates everything else. This is what Taleb calls extremistan, where a small number of people have a huge portion of wealth, while others have very little. Taleb argues that the modern world operates more like money. It's mostly digital and not constrained by physical or biological limits. While most people don't make a lot of money, a few can make a ton. The same applies to other areas like music, book sales, and more. This winner-take-all system rewards a small number of individuals disproportionately. We tend to believe we understand why these outliers exist. We think it's all about thinking outside the box, starting a revolutionary company, and working tirelessly. But what about those people who did all these things and failed? You don't often hear about them or find shelves full of books about their failures. There's a bias in the stories we hear and the information available to us. In the end, we became more vulnerable to black swans. So, whether it's a mold leading to life-saving antibiotics or an economic crisis, these events of the black swan theory show us that unexpected events can have impacts on our lives. By the way, the odds of being born are 1 in 400 trillion. For all we know and don't know, being born is an unimaginably improbable event that nobody could have truly foreseen. So if you're alive, in a sense, you're a black swan too.
People stop their cars on the highway, get out of them, and lift their heads in wonder. In the cities, everyone takes to the streets. Balconies and rooftops of houses are full of people staring at the moon in shock. It's red. Some people scream that it's the end of the world. Some seek shelter. Indeed, the usual white moon now looks like it's been doused in red paint. There's no need to be afraid if you see such a thing. On the contrary, enjoy the view, because you have witnessed a rare astronomical phenomenon. This is a total lunar eclipse. Here's the sun. It's in the center of our solar system. Mercury, Venus, and here's Earth and the moon. The Earth takes 365 days to orbit around the star. At the same time, the moon revolves around the Earth and completely orbits our planet in 27 days. The Earth creates a shadow zone, and sometimes the moon passes through it. The shadow is cone-shaped and gradually narrows. The moon is 238,000 miles away. That's like 9 lengths of the equator. At this distance, the width of the shadow is about 2.6 times the width of the moon. When the moon is in this zone, direct sunlight doesn't reach it. That is, it should have disappeared, but instead, it becomes red. All because the sun's rays pass through the Earth's atmosphere. They scatter, and most of the blue light disappears. But the red and orange rays continue and hit the surface of the moon. Voila! You see a phenomenon called the blood moon. By the way, this curvature of light occurs at sunsets and dawns. The atmosphere scatters the blue light, and you see a red and orange sky. If you were standing on the surface of the moon during a total lunar eclipse, planet Earth would be exactly between you and the sun. So you would be able to observe the solar eclipse. The surface of the Earth would become entirely dark for you. All you'd see would be the sun's corona illuminating the edges of the planet. The Earth from the surface of the moon is almost the same size as the moon from the surface of the Earth. Such a red eclipse of the moon is rare because several factors must coincide. One of them is that the moon must be full. Usually, you can see 2 total lunar eclipses a year. In 2038, you'll be able to see 4 such eclipses, and the eclipse itself can last up to 108 minutes. But this is rare, and the last time such a long blood moon was seen was in 2000. Many years ago, people didn't know so many facts about our satellite, and the sight of a red moon frightened them. It was a bad sign and a harbinger of trouble. People who knew the schedule of eclipses could take advantage of it. For example, Christopher Columbus had an astronomical almanac and knew when the next lunar eclipse would occur. He frightened the inhabitants of the Caribbean islands when he predicted the red moon. Once upon a time, the moon used to be a red ball of lava. This was way back in time, 4.5 billion years ago. Now this is our solar system. It's full of dust and asteroids. They're constantly bumping into each other, playing space billiards. This is Earth. It's just beginning to cool off from the constant asteroid and comet impacts. But then, Theia appears on the horizon, a planet the size of Mars. It had a chaotic orbit and was approaching Earth in a spiral. A collision was inevitable, and at one point, one of the biggest crashes in our solar system occurred. Theia struck the Earth at an angle. It ripped out part of the Earth's crust and threw it into space. The Earth, in turn, absorbed part of the planet that rammed it. The debris from the collision circled the Earth for a long time. They were a kind of ring, almost like Saturn's. Debris in orbit collided and piled up around a common center of gravity. And that's how the Earth got the moon. There's a theory that this collision helped give birth to life on our planet. Theia hit the Earth at a perfect angle. If the crash had been head-on, both planets would likely have been destroyed in a massive explosion. If the impact had been tangential, then there wouldn't have been enough debris in Earth's orbit to form the moon. But we got the lucky ticket. The moon stabilized the Earth's rotation. The collision shattered the planet's solid crust and allowed oceans to form. Remember, water is the basis of life. When the cores of Earth and Theia merged, we got a powerful magnetosphere. This protects all living organisms from solar radiation. The moon, along with the sun, controls the tides. Its gravity seems to draw water to it from the Earth's surface. The sun does the same thing. That is, if we imagine the Earth as a ball of water, there would be two mountains, one on the moon's side and one on the sun's side. And as the moon moves around the Earth, this mountain of water moves with it. If you were in the open ocean with a tape measure, you would see that the moon is attracting water to itself by about 4 to 6 inches. The moon is gravitationally locked with the Earth. That's why it's always turned to us with one side, like Mercury and the sun. But the moon doesn't stand still. It's gradually moving away from our planet, about 1.5 inches a year. Not quickly, but in about 600 million years, it will have shrunk in our sky so much that we won't be able to see lunar eclipses anymore. Do you see this crater? It's Tycho. It's visible during a full moon because of these bright rays that extend thousands of miles from its epicenter. This is the youngest crater on the moon. Scientists say it appeared there due to a meteorite impact about 109 million years ago. At that time, dinosaurs were roaming the surface of our planet, and they may have seen the impact. It was most likely accompanied by a big explosion and looked like a salute in the night sky. Humanity loves to explore the moon. We've sent a bunch of missions there. A total of 12 people have set foot on the surface of the moon. The gravitational force there is 6 times less than on Earth. So if the average person on our planet weighed about 180 pounds, on the surface of the moon, the scales would only show 30 pounds, like the weight of an average dog. That's why the astronauts moved, jumped, and fell so strangely there. And you would be 6 times stronger on the surface of the moon. Here on Earth, the average person could lift about 130 pounds, but on the moon, you could raise a big motorcycle or a grizzly bear. The surface of the moon is covered with regolith. This is the lunar dust that covers the solid ground. Such dust is good at preserving footprints. Here's the most famous footprint, which gave birth to many crazy theories. Here's the footprint, and here's the shoe that left it. But the shoe is completely flat. This is explained simply. The astronauts wore extra boots for walking on the lunar surface. They have exactly the kind of sole that left these marks. In addition to the footprints, we left many fascinating objects on the moon. Several lunar rovers, a golf ball, flags, and human waste. There's also a lot of broken satellites and rocket parts. All in all, about 413,000 pounds of human-made objects are there. That's the weight of 3 passenger planes, or 31 adult elephants. In the future, we plan to resume missions to the moon. New landers will explore the surface of our satellite to find natural resources there. It's also a great place to test new rovers. We're even going to build something like the International Space Station in the moon's orbit, the Lunar Orbital Platform Gateway. It'll be a convenient platform for exploring our satellite and launching spacecraft into distant space. If you start from here, the spacecraft won't need to spend almost all its fuel to overcome the force of Earth's gravity. So, such a station would save fuel and money. Scientists hope that we'll be able to mine water from the moon's surface. It's been proven that there's ice there, mostly at the bottom of craters where the sunlight doesn't reach. Perhaps we'll send a rover there that can drill down a few feet into the surface, searching for water. Humanity already has the technology to build a full-fledged colony there. It would take up to 3 days to get there. We just need to get enough solar panels and building materials to the moon. There's no atmosphere on the moon, so potential lunar inhabitants would be defenseless against solar radiation. We would have to build houses underground to provide protection. Modern 3D printers will help make construction easy and fast. However, food and water supplies can only be maintained by constant supplies from Earth. The same goes for oxygen. Each rocket launch costs millions of dollars, so for now, colonization of the moon is in question. The moon could also become an object for space tourism. Imagine a spaceship launches from Earth, 3 days on the road, and you're orbiting the moon. The lunar module undocks, and you land on the surface. You ride the rover, explore the craters, then return to the lander. The engines start, the lander returns you to orbit. You dock with the ship and return to Earth. Sounds like some pretty great plans for a week's vacation.
The universe is expanding, and if it's expanding, then it probably had a beginning somewhere. Now, all we have to do is to run time backward and see where the beginning was. It took the scientists many more years to come up with a full-fledged theory, the Big Bang Theory. And here it is. Nothing has ever been anywhere, because neither when nor where existed. But actually, no. There was one thing. It was the so-called cosmic singularity, a state of our universe in which it was incredibly small, dense, and very, very hot. Imagine if our universe was compressed into a small ball. The pressure and temperature inside would be enormous. At some point, it became impossible to withstand them. And here comes the Big Bang. It was an outburst of energy and matter that created everything we see now. Time and space, basic physical forces. It also scattered quarks everywhere. These quarks, tiny particles that make up our world, were all boiling in an incredibly hot cosmic broth. When it cooled down, gravity began to attract them to each other. They gathered into atoms, then molecules, and then into the first objects in the world, stars. But what was before that? Alan Harvey Guth, an American theoretical physicist and cosmologist, has devoted his whole life to solving this mystery. After learning about the Big Bang Theory, Guth found some flaws in it. For example, the distribution of matter was very even, although it shouldn't have been. If we drop the balloon filled with paint down, it will burst. We'll see absolute chaos on the canvas. But the early universe don't look like. The early universe was very even and proportional. That was Guth's discovery, the theory of inflation. Here's what it says. Even before the Big Bang, there was some kind of force that could give the bang a strong acceleration, something that was able to distribute everything in space instantly and evenly. Martin Boyovald is a German professor of physics, and in his opinion, the universe was born quite differently. According to Martin's theory, the singularity couldn't just appear out of nowhere. Let's look at a pendulum on the old clock. The pendulum rotates back and forth. Its movement is smooth, continuous, and non-stop. This is how we usually see time. It flows and never stops. But quantum time doesn't work that way. It consists of small segments and makes short pauses. And just like with the second hand of a clock, the beginning of one segment of time is always the end of another. According to the Big Bang Theory, once upon a time, our universe began to expand, inflate like a balloon. But sooner or later, it will blow away back. The universe will start shrinking and return to the state of cosmic singularity. And then, the Big Bang too. Nothing appears out of nowhere and disappears into nowhere. According to Boyovald's theory, the beginning of each universe is the end of the previous one. Our universe is not at all the first and not the last. Millions of similar universes existed before us and will exist after us. This theory, although it sounds very logical, is far from complete. So for now, all this is just a hypothesis. But some people come up with even stranger ideas. Neil Turok, a South African physicist, and his colleague Paul Steinhardt, an American theoretical physicist. They say that yes, our universe isn't the first one. Our universe is just one of an infinite number of others. And all of us are stuck in a cycle of endless rebirths of parallel worlds. According to this theory, our universe is located inside a so-called brain, as in membrane. In other words, we're stuck in some kind of elastic surface that's capable of contracting, stretching, oscillating, and so on, like pieces of fabric on a rope. Another universe may be an inch from ours, but we can't see it. That's because there's a tiny space between us, and this tiny space contains the fourth dimension. How do these universes originate? Through brain collision. These brains are getting closer to each other very, very slowly, until they finally collide. Their collision creates two big bangs and two parallel universes. Then they're moving away from each other. The created worlds continue to live. We're currently at this stage. Remember the inflation theory? There was a mysterious energy that pushed and accelerated the Big Bang. Well, if we did collide with another universe, that would explain everything. Which idea is closer to you? How about the idea of subscribing? Subscribe.
Now, think about the vastness of the universe. Our galaxy contains between 100 and 400 billion stars. Many of them can potentially host planets. Many of those planets might have water in them and be capable of supporting life. And this is just the Milky Way alone. What's the likelihood of other intelligent civilizations existing out there? Well, there's a famous formula called the Drake equation. It's a mathematical tool to guess how many civilizations from outer space might be able to talk to us in our Milky Way galaxy. It was made by a scientist named Frank Drake in 1961. Here are the variables in it. N is the number of civilizations we could potentially talk to in our galaxy. R star is how fast new stars are born in our galaxy. F sub p is the fraction of stars with planets around them. N sub e is the average number of planets around each star that could support life. F sub L is the fraction of those planets where life might actually start. F sub I is the fraction of planets with life that could become smart civilizations. F sub c is the fraction of smart civilizations that send signals into space. And L is how long those civilizations keep sending signals. Of course, we won't get an exact number like this. It's more like an educated guess, and we don't have any answer to that. But based on at least some information we know, there might be around 100 million worlds where life should have evolved. But if that's the case, then why haven't we met or heard from anyone? This is called the Fermi paradox. It's named after the famous physicist Enrico Fermi. He asked a simple but very important question: where is everybody? Our universe should be filled with chatty extraterrestrial beings, advanced civilizations, and spaceships zipping around. Yet, when we look up at the night sky or listen with our radio telescopes and antennas, it's eerily quiet. All we get is the so-called Great Silence of the universe. Scientists from Oxford University's Future of Humanity Institute are trying to answer this question. And they're not the only ones. A group called METI, for Messaging Extraterrestrial Intelligence, organized a workshop in Paris in 2019 to explore this mystery. The workshop brought together experts from various fields, like astrophysics, biology, psychology, and so on. One of the ideas discussed is called the zoo hypothesis. It suggests that perhaps other civilizations do exist, but they're simply not broadcasting their presence. Maybe they know that making direct contact with us could be risky for both sides. So they're intentionally avoiding us because they're watching us like observing a zoo. They could be using advanced technology we can't detect. There are also some optimistic explanations, like time delays. Space, as you know, is unimaginably big. The time it takes for signals or information to travel across the universe is enormous. It's possible that other civilizations exist, but their signals haven't reached us yet, or ours haven't reached them. But some explanations aren't very optimistic. Like, some scientists think Earth might really be unique. Maybe the conditions that led to life and intelligent beings are so incredibly rare that there are no other planets like ours. Scientists point out that there are many planets similar to Earth, and some are much older. This means there should be plenty of planets where life could evolve. Recent research also suggests that life might be way more resilient than we thought. And, well, while it increases the amount of life existing out there, it also increases the chances that intelligent life doesn't last very long. It might destroy itself before it can spread to other parts of the universe. This is a concerning idea for the future of humanity. The researchers also considered that many planets might be at a similar stage in their development. That's why it's hard for them to explore the universe at the same time. But even they agreed that this explanation is way too far-fetched. And finally, one of the big potential explanations is called the Great Filter. This idea was suggested in the 1990s by Robin Hanson. It says that for life to develop and become advanced like us, it has to overcome some really tough challenges. First of all, the planet itself should have a good stable star and good enough conditions on it. Then life has to start on that planet. These life forms need to be able to reproduce using things like DNA. Simple cells must evolve into more complex cells. More complex organisms with multiple cells must develop. And eventually, these organisms must figure out how to reproduce, which increases genetic diversity. And finally, these organisms must be smart enough to use tools, create, and explore things. Finally, they should colonize other planets and star systems without destroying themselves. And maybe one of these stages is so incredibly hard that most civilizations don't make it past that point. This challenge could be something like developing intelligence in the first place, or it might be the struggle to avoid self-destruction. So, perhaps life isn't rare at all, but most of it doesn't go beyond simple tiny organisms like bacteria. Even if the universe is full of bacteria, they don't become advanced enough to build spaceships. The Great Filter might also be something from outside, like a huge asteroid crashing into a planet, a dangerous burst of gamma rays, or a massive star going supernova. These events could destroy life on any planet, no matter how advanced they are. So, if we've already passed this challenge, it means we could be the only ones in the universe and we can explore it. But if we suddenly hear from a super advanced civilization, it could mean the hard part of the challenge is still ahead of us. Now, the Fermi paradox focuses on intelligent civilizations. It just implies that there should be civilizations more advanced than us, or at least as intelligent as us. But if you think about it, why should extraterrestrial life be similar to ours at all? It might be completely different for many important reasons. Life elsewhere might have developed under completely unique conditions. This could lead to forms of intelligence and consciousness very unlike our own. For example, it could have evolved into highly advanced forms that aren't based on biology as we know it. These beings could exist as energy-based entities, silicon-based life forms, or even as a hive mind. And because they have evolved completely differently, they may be capable of things that we aren't capable of. For example, we can't see the entire light spectrum. Our eyes also can't perceive cool things like dark matter. But who knows what the vision of extraterrestrial beings may be capable of? Their abilities might even extend beyond our three-dimensional perception. They might be able to perceive and interact with higher dimensions, which is why they could have unique, interesting insights into the nature of our world. Or maybe they've learned to think outside of time, like in the movie Arrival. For us, we still haven't met them, but for extraterrestrial beings themselves, the concept of time doesn't exist at all. They're simultaneously in the past, present, and future. For humans, something like this is hard to even imagine. Plus, even on Earth, we don't fully grasp how consciousness works or why it exists. We're not even sure when exactly we became conscious. So even if we do encounter extraterrestrial life, it will be hard for us to understand them or communicate with them. We think that they might have entirely different language systems, symbols, and so on, but they might not even have any communication systems at all. As you can see, the possibilities are endless. Evolution is a process that can go in many different directions. It's possible that extraterrestrial life developed in ways we can't easily understand or even imagine. These things are intriguing to think about. There are still no easy answers. The Fermi paradox remains one of the most exciting and mystery questions in science. Scientists continue to explore these mysteries through a multidisciplinary approach. They're hoping to find clues that could lead to breakthroughs in our understanding of alien intelligence. And until we find a definitive answer, we can keep sparking our curiosity and imagination. Now, you wake up one morning and watch the news while having your morning coffee. They did it again! Those scientists! The news anchor yells on the TV. A report was released a few days ago that the moon is moving further away from Earth's orbit. Its distance extends 2 inches per year. Over the past 2,000 years, it's drifted a total of 260 feet. This isn't too daunting of a distance, but the news has still made people panicked and concerned. They rally together around the planet, uniting to try and stop the moon from escaping Earth's orbit, even though it won't actually leave the orbit for over 1 billion years. But everyone was focused on the past benefits of the moon. It's obvious life on Earth as we know it wouldn't have evolved without its existence. The moon is controlling the tides and the molecules in the atmosphere. Without it, humans, in particular, wouldn't have evolved. So, with an appreciation of the moon, the top brass ordered the best scientists to come up with a solution to push the moon closer towards the Earth. A giant thruster engine was built on the dark side of the moon. It was ignited, and the thrusts tried to push forward, but the startup power wasn't strong enough to push the moon. Instead, it tilted the moon's axis, rotating it slowly. As the moon rotated, the scientists hurried to turn it off before the engine reached its full power, as it was headed off course. The brass didn't accept this and ordered them to continue with the objective. The scientists insisted the math wasn't correct and didn't know exactly what may occur. Their concerns were ignored, and they watched as the engine's power increased. The engine slowly pushed the moon, the distance reducing. But as it was provided at the wrong moment, the angle it was aimed at would provide complications. The thrust and gravity from the Earth ensured the moon followed the orbit at a reduced distance. But with the combination of the initial thrust on an indirect angle, the moon was directed away from the Earth, quickly moving further off its trajectory on a path to leave the orbit altogether. As you finish your breakfast and turn the TV off, you go outside to look at the moon. It sits high above, seemingly fine. Surely, the news anchor was just exaggerating. You go to work. The issues of the moon are now just an afterthought. Even if it was true, how could it possibly affect your day? The morning feels normal, just another day at the office, as it turns out. During your lunch break, you head into town and notice on your way that the wind is picking up, getting stronger and colder. It must be a storm approaching. You quickly check on the moon. It appears smaller, about half the size of what it was this morning. But it's midday, so it's supposed to be that size, isn't it? After you finish your meal at the restaurant, you leave to find it's becoming darker. The wind is much stronger than earlier, but there are no storm clouds in the sky. People in the streets are pointing towards the sky, shocked at something, probably an eclipse. As people begin running in the streets frantically, you look above and can't see the moon. Confused by everything, you decide to head home for the day. When you arrive home, you turn on the TV. The news anchor, who is now more serious than earlier, explains that the moon has left the Earth's orbit altogether and is flying off somewhere into space. The loss of the moon means the daily cycle has changed. Now, there are only 6 to 12 hours of sunlight a day and over 1,000 days per year. I only have to work half as much, you say excitedly, pumping your arms in the air. The lack of the moon creates a completely different world. The pull of the moon's gravity is what keeps the Earth in a place at 23.5 degrees angle, ensuring the weather patterns and normal days that we're accustomed to. Baffled by all the scientific information, you go outside to just confirm you aren't being pranked. The shorter working week seems too good to be true. As you look out into the sky, you notice the stars are brighter than you have ever seen. You can clearly see the outline of the Milky Way's arms. The stars are far more numerous than you remember, with Venus glowing far brighter than them all. It's a beautiful sight, but you're not sure whether a clearer night sky was worth the moon's removal. You have never been interested in astronomy. You decide to go to bed. It's a good idea to adjust to the new night and day cycle. You set your alarm for 2 hours. That should be enough, you say to yourself happily. Tomorrow is Saturday after all. You need to get up early to go surfing. Gotta catch those high tide waves. You wake up, get your things together, and drive to the beach. The news on the radio explains some issues about how the Earth is now more defenseless to asteroids without the moon. Then they talk about some issues with the tides. Something about how the tide is now 1/3 the size it used to be before. You're unsure how this could affect the waves. Maybe it means they will be larger. You park at the beach, grab your board, and look towards where the surf should be. It should be high tide, but the sea is somehow a lot further away than normal. You shrug off the hurdle of having to walk towards the water. After a long, enthusiastic walk toward the gnarly waves, your mood changes as you approach, staring blankly at the tiny waves. Upset, you head home. While driving, you listen to the news and pay more attention to the information provided. In place of structured seasons, there are only erratic weather patterns. Winds are faster and stronger, creating more powerful storms, and in some places, there are just stagnant conditions. The equator is no longer always warm. The poles aren't constantly cold. The depths of water shrink. Tides only adjust to the sun's gravity, reduced to 1/3 of the pre-moon depths. Throughout the world, the seas change in altitude, shrinking at the poles, and the bulge of water around the equator shifts. The moon regulated the tides and provided the periodic changes that were a key element to assisting with life on Earth. Aquatic life forms are displaced within shallows worldwide. Life cycles of important microbial life have been upset. You couldn't imagine that something as simple as a change in the tides could be so important to billions of life forms. Water and precipitation, which is distributed across the globe, cannot provide sustenance where they did before. The weather has become more extreme, hotter for longer periods and colder for other parts of the Earth. Over time, some thousands of years in the future, dry deserts will transition into ice ages. These intense changes disrupt the natural order of all things for life on Earth. Not only did the moon control the tides and weather, but it used to pull molecules within the atmosphere as it moved. The now constant movement disrupts molecules, creating barriers for future evolution. You arrive home, upset after learning the disheartening news. Not only will you never be able to surf again, but all life on Earth will change. An age of devolution has begun. Over the next year, flora and fauna changed to adjust to this new world. Migratory animals that would travel toward greener pastures find nothing at all. Birds are completely confused, with no end to the change in seasons. Hibernating animals delve in and out of their shelters at the incorrect times, and vegetation struggles to grow at the lack of sunlight. Nocturnal animals cannot see without guided assistance from the reflection of the moon. Although Venus is the brightest source of light when it's dark, it's only 1/1000th of a fraction as bright as the moon was. Predatory animals that hunt during the night are not capable of finding their prey, providing an opportunity for smaller animals to thrive. Although life on Earth has changed, it will continue to exist. But the sudden adjustments will become a test for all walks of life. Over time, It will be very interesting to see what species have adapted and evolved. A world where rats and mice would be more prominent due to their adaptive capabilities could create a new dominant species to emerge. In millions of years of evolution, their descendants will primarily flourish. We could see buffalo-sized mouse herbivores crossing the plains and tiger-sized rats roaming within the jungles. Tree-faring mice with long arms may swing amongst the branches. Others will probably move to the seas in place of mammals to feed upon aquatic life. Wide-eyed predatory rats may occur to have similar traits to bats, with echolocation, becoming the conquerors of pitch-black nights. All the new species that will emerge, undoubtedly, will continue to be monitored by humans, wherever we may be. If you could track the line of evolution and go back an exceptionally long time ago, you'd see some weird creatures called Ediacarans. It seems like these little fellas made of tubes showed up 579 million years ago. They thrived at the bottom of the ocean for about 37 million years, chilling and minding their own business. It continued until they disappeared, or better yet, turned into faint marks we now only know from the sandstone fossil record. The world started to change for these ancient creatures somewhere around 541 million years ago, when a lot of new life forms came into being. Some new creatures began to evolve, and it's possible they might have replaced our friends. They might have changed the environment in ways that made it hard for these poor fellas to survive. Why does this even matter that much? It was the first time when a complex life form went extinct because of other living things. Usually, when you hear about lots of creatures vanishing from the face of the Earth, it's due to something like a giant volcanic eruption poisoning the oceans, or a big space rock slamming into our planet. For example, 440 million years ago, a big change in the planet's climate happened. The water in the oceans became colder, and it wiped away a lot of ocean life. The southern part of a big landmass called Gondwana ended up covered with ice quickly. This made a lot of Earth's water turn into ice, which, again, caused the sea levels to drop. Creatures from that time were struggling to find food. Plus, they didn't have homes where they could evolve, live, and reproduce. Then there was this interesting period called the Age of Fishes, when a wide variety of different sea creatures appeared on Earth. Even though some animals were starting to live on land, most of the action and fun was still in the oceans, at least until the moment when trees and plants ruined the party. Their roots started growing on dry land, and it transformed the world, turning rubble and rock into soil. This was fun for land animals, but it gave all those fellas in the ocean depths a lot to worry about. The soil, rich in nutrients, got into the oceans, which made a lot of algae grow in the water. These blooms eventually caused enormous dead zones, where algae took away oxygen from the water. So lots of marine animals that were simply fine living their peaceful lives in the ocean couldn't breathe there anymore. Plus, they didn't have enough food to survive. Or we can talk about the biggest extinction event called the Great Dying, 253 million years ago, when almost 90% of all species on Earth vanished, including many land creatures such as insects, reptiles, and amphibians. This happened because of insanely strong volcanic eruptions. When you see what happened in the past during these extinction events, you can understand better why the case of Ediacarans is so intriguing. Researchers haven't found any evidence that low oxygen levels or some other troubles that might have happened in their environment could have caused them to disappear. Also, they've agreed that conditions weren't that bad, since the creature's fossils remain intact. They look for answers in southern Namibia, studying rocks that contain fossils from the time when ancient creatures vanished, and new ones came to the scene. Researchers found many traces of these new ones left behind. Modern animals are like architects of their environment. They change things around them, dig into the ground, and eat one another. But if they caused ancient creatures to disappear, the remains of those species had to show some signs of struggling, something the fossils from Namibia indicated. Traces were similar to predatory sea anemones. Well, you know what I'm trying to say. How did tiny, simple cells even turn into such complex organisms anyway? Throughout time, they got bigger and ended up with nuclei and mitochondria, parts that help cells work, but it's still not completely clear what really happened here. The most accepted theory is that mitochondria, which are like the powerhouse of the cell, came from a kind of bacteria that got inside another bigger cell. This bigger cell started to change over time, developing more parts, like the nucleus. This way, a cell became stronger and more complex. That sounds cool, but we can't be sure of this. One of the problems with this idea is that we don't see cells in between the simple and complex stages. There's also a new theory that says that the first step toward complex forms of life involved a bacterial cell that formed bumps on its surface. These bumps trapped similar bacteria, which then helped the cell get bigger. As it grew, the bumps turned into parts, and some of these parts later turned out to be useful, such as endoplasmic reticulum, the outer nucleus membrane. More and more parts started developing, which meant increasingly complex forms of life. And the most complex known creature that we ended up with is this tiny transparent water flake. It has 31,000 genes, which is 25% more than what humans have. This water flea is especially interesting because it can transform its shape when things get tough. It can grow spines, helmets, or even teeth depending on its surroundings, and this might be because it has so many genes. Scientists copied its genes, and instead of staying the same, they quickly changed their roles to adjust to the environment. Researchers believe the copied genes would stay the same and only change later, so this was a bit of a surprise. And this interesting creature even has some genes like ours. This may help us understand our own kind better. For instance, how humans react to different threats in the environment, and how we can improve things that negatively affect our health. Or imagine if we could grow some of those cool additional organs like this water flea. The first complex forms of life are older than we thought. 1.6 billion years ago, there was a happy community of small, bright red things that looked like plants. It was flitting around in a shallow pool of ancient waters and eventually ended up trapped in rocks and preserved till the end of time. A few years ago, scientists from Sweden found these fossils in India and concluded that they could be red algae. Using a special method, they carefully extracted them from the rock and discovered two types of red algae, one that looked like a segmented noodle and the other with layers of cells. To understand them better, the researchers made 3D models of them and used radioactive dating to confirm their age. If that's true, they're almost 500 million years older than we previously thought. A very long time ago, our home planet was hot because of all those things slamming into its surface, like asteroids and comets. This made it difficult for life to start there. But about 3.8 billion years ago, these hits slowed down, and life finally appeared on Earth. At first, those were simple life forms, but then more of these space objects hit Earth, and it's possible some of them brought water and other stuff important for life. Some life forms survived these hits and finally had a chance to evolve. However, we still don't have unambiguous evidence of how it all started, so no one is sure if life on Earth appeared just once or multiple times in unusual ways. Our planet had building blocks, which are elements important for the appearance of life, even a long time ago. These blocks could have appeared naturally or might have come from space rocks. As they joined together, they formed more complex things like proteins, fats, and DNA. And maybe this process happened more than once. Someday, we'll find the answers because it will help us understand not only our planet, but the odds of life emerging on other planets too. If you could track the line of evolution and go back an exceptionally long time ago, you'd see some weird creatures called ediacarans. It seems like these little fellas made of tubes showed up 579 million years ago. They thrived at the bottom of the ocean for about 37 million years chilling and minding their own business. It continued until they disappeared, or better yet, turned into faint marks we now only know from the sandstone fossil record. The world started to change for these ancient creatures somewhere around 541 million years ago, when a lot of new life forms came into being. Some new creatures began to evolve, and it's possible they might have replaced our friends. They might have changed the environment in ways that made it hard for these poor fellas to survive. Why does this even matter that much? It was the first time when a complex life form went extinct because of other living things. Usually, when you hear about lots of creatures vanishing from the face of the Earth, it's due to something like a giant volcanic eruption poisoning the oceans, or a big space rock slamming into our planet. For example, 440 million years ago, a big change in the planet's climate happened. The water in the oceans became colder, and it wiped away a lot of ocean life. The southern part of a big landmass called Gondwana ended up covered with ice quickly. This made a lot of Earth's water turn into ice, which, again, caused the sea levels to drop. Creatures from that time were struggling to find food. Plus, they didn't have homes where they could evolve, live, and reproduce. Then there was this interesting period called the Age of Fishes, when a wide variety of different sea creatures appeared on Earth. Even though some animals were starting to live on land, most of the action and fun was still in the oceans, at least until the moment when trees and plants ruined the party. Their roots started growing on dry land, and it transformed the world, turning rubble and rock into soil. This was fun for land animals, but it gave all those fellas in the ocean depths a lot to worry about. The soil, rich in nutrients, got into the oceans, which made a lot of algae grow in the water. These blooms eventually caused enormous dead zones, where algae took away oxygen from the water. So lots of marine animals that were simply fine living their peaceful lives in the ocean couldn't breathe there anymore. Plus, they didn't have enough food to survive. Or we can talk about the biggest extinction event called the Great Dying, 253 million years ago, when almost 90% of all species on Earth vanished, including many land creatures such as insects, reptiles, and amphibians. This happened because of insanely strong volcanic eruptions. When you see what happened in the past during these extinction events, you can understand better why the case of Edacarians is so intriguing. Researchers haven't found any evidence that low oxygen levels or some other troubles that might have happened in their environment could have caused them to disappear. Also, they've agreed that conditions weren't that bad since the creature's fossils remain intact. They look for answers in southern Namibia, studying rocks that contain fossils from the time when ancient creatures vanished and new ones came to the scene. Researchers found many traces of these new ones left behind. Modern animals are like architects of their environment. They change things around them, dig into the ground, and eat one another. But if they caused ancient creatures to disappear, the remains of those species had to show some signs of struggling, something the fossils from Namibia indicated. Traces were similar to predatory sea anemones. Well, you know what I'm trying to say. How did tiny, simple cells even turn into such complex organisms anyway? Throughout time, they got bigger and ended up with nuclei and mitochondria, parts that help cells work, but it's still not completely clear what really happened here. The most accepted theory is that mitochondria, which are like the powerhouse of the cell, came from a kind of bacteria that got inside another bigger cell. This bigger cell started to change over time, developing more parts, like the nucleus. This way, a cell became stronger and more complex. That sounds cool, but we can't be sure of this. One of the problems with this idea is that we don't see cells in between the simple and complex stages. There's also a new theory that says that the first step toward complex forms of life involved a bacterial cell that formed bumps on its surface. These bumps trapped similar bacteria, which then helped the cell get bigger. As it grew, the bumps turned into parts, and some of these parts later turned out to be useful, such as endoplasmic reticulum, the outer nucleus membrane. More and more parts started developing, which meant increasingly complex forms of life. And the most complex known creature that we ended up with is this tiny transparent water flea. It has 31,000 genes, which is 25% more than what humans have. This water flea is especially interesting because it can transform its shape when things get tough. It can grow spines, helmets, or even teeth depending on its surroundings, and this might be because it has so many genes. Scientists copied its genes, and instead of staying the same, they quickly changed their roles to adjust to the environment. Researchers believe the copied genes would stay the same and only change later, so this was a bit of a surprise. And this interesting creature even has some genes like ours. This may help us understand our own kind better. For instance, how humans react to different threats in the environment, and how we can improve things that negatively affect our health. Or imagine if we could grow some of those cool additional organs like this water flea. The first complex forms of life are older than we thought. 1.6 billion years ago, there was a happy community of small, bright red things that looked like plants. It was flitting around in a shallow pool of ancient waters and eventually ended up trapped in rocks and preserved till the end of time. A few years ago, scientists from Sweden found these fossils in India and concluded that they could be red algae. Using a special method, they carefully extracted them from the rock and discovered two types of red algae, one that looked like a segmented noodle and the other with layers of cells. To understand them better, the researchers made 3D models of them and used radioactive dating to confirm their age. If that's true, they're almost 500 million years older than we previously thought. A very long time ago, our home planet was hot because of all those things slamming into its surface, like asteroids and comets. This made it difficult for life to start there. But about 3.8 billion years ago, these hits slowed down, and life finally appeared on Earth. At first, those were simple life forms, but then more of these space objects hit Earth, and it's possible some of them brought water and other stuff important for life. Some life forms survived these hits and finally had a chance to evolve. However, we still don't have unambiguous evidence of how it all started, so no one is sure if life on Earth appeared just once or multiple times in unusual ways. Our planet had building blocks, which are elements important for the appearance of life, even a long time ago. These blocks could have appeared naturally or might have come from space rocks. As they joined together, they form more complex things like proteins, fats, and DNA. And maybe this process happened more than once. Someday, we'll find the answers because it will help us understand not only our planet, but the odds of life emerging on other planets too. Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire Moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the Moon's surface and its core, called the mantle, has been moving around as the Moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the Moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the Moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve: what caused the Moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the Moon's magnetic field. Knowing what the inner core is like can help us better understand the Moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the Moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the Moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, So they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
It's September 1977. You're playing one of the first video game consoles released in North America. You step outside and see the whole neighborhood waiting for Voyager 1 to launch. It's a super sunny day, so you squint a little, trying to see what's happening. You live in the neighborhood right outside the launching station. You get yourself some food and watch the Voyager take off into space. You're so impressed, you decide to dedicate your career to working with NASA. 35 years later, you're now a senior official in NASA, specializing in Voyager 1. It's 2012, and you're sitting in the control room with your colleagues. Everyone is staring at their computer screens as they work on the Voyager. You're sitting on the top, overlooking everything and making sure all systems are in check. This day is special, as Voyager 1 is about to exit the heliosphere, which is a science word for the outer shell of our solar system. It's a bubble of space affected by the solar wind, which comes from the sun. By 2021, it got 14 billion miles away from Earth, which is equivalent to 153 astronomical units from the sun. 1 astronomical unit is the distance between the sun and the Earth. The craft was originally meant to fly by Uranus, Saturn, and Jupiter, and toss itself from one planet to another with the use of their gravitational pull. Everyone is impatiently waiting for it to exit the heliosphere. 3, 2, 1, and it's officially out. All systems are normal and functioning. You praise your team for doing an excellent job. With Voyager 1 reaching this far, there's still tons to explore in outer space. You were once a young adult watching the craft launch outside your neighborhood, and now you're the main person in charge of the operation. 9 years later. Since Voyager 1 left the heliosphere, you've been checking up on it every now and then, making sure all systems and functions are in order. It's been sending back measurements of the interstellar medium. It's the area between the stars of our galaxy, consisting of ionized materials. Ionized is basically a simple version of a molecule or substance. The interstellar medium is an electrically charged state of plasma, or ionized plasma, and is very unstable. It's like going from lightning in a thunderstorm back to calm rain in a matter of seconds. The plasma up there is different than the plasma on Earth, in that it's difficult to filter out. There are around 0.06 atoms for every cubic inch in the interstellar medium. The air we breathe on Earth has billions of atoms. By measuring the plasma in the interstellar medium, we can further understand the behavior and structure of chemicals and gases. It's possible that the oxygen we know and love on Earth is different than the ones out there. One of your main tasks is to learn more about how the solar wind from the sun and interstellar medium interact with each other to create the heliosphere. So, after doing some routine checkups and other maintenance work on Voyager 1 from the control room, you notice something strange coming from the screen. You sit in front of the computer, crunching the numbers of the plasma vibrations and convert them into an audio file of about 3 kilohertz. You click on it and listen to an eerie, subtle hum. You and your team are surprised that these vibrations occurred in such a small frequency. Given that space is massive, something like this might mean life on other planets. Everyone else at the station rushes to the control room to listen to that sound from outer space. It's monotonous and faint, but it's definitely coming from outside the heliosphere. You run the numbers over and over to make sure it's not a fluke, but it's on point. You make sure your team doesn't spill the beans to anyone outside until everything is known and clear. You get into beast mode with work and try to catch the sound again, and it remains. You can't sleep trying to think of something that could be producing this hum. A few days pass by, and the sound is pretty consistent. If there was some life out there trying to communicate with you, then surely it would have said something that can be deciphered. You analyze the audio files once again, trying to see if it's some phonetic language you don't know. You call in a linguist to see if she can make something out of it. You and the squad gather around, waiting impatiently for some answers. After a while, she believes that it might be someone out there communicating with us, but the only way to find out is by sending something back to them. You arrange a meeting with your team and try to figure out what message you can send. After much thinking and lots of coffee, you decide to send them one phrase in English. Who are you? You send out the signal through Voyager 1 and wait for any changes in the hum, but you don't get anything straight away. It may take some time for a response. You wait all night and still, there's nothing. It's starting to look like there isn't anything out there. For the next couple of days, you keep sending out phrases for anything to pick up. Since space is a vacuum, sound waves can't travel, so sending out voice messages on a large speaker won't work. You locate the source of the humming and aim for it when sending the audio file. Every day, you send something different, but still, you don't hear anything from them for a week. It seems that intelligent life in the distant world isn't real. The areas between the star systems in a galaxy aren't necessarily a complete vacuum. That's where the interstellar medium is. It contains gases, dust, and cosmic rays, which are energy particles. After many months of this constant humming being produced, you still try to figure out what's going on. You sit there, remembering the time when the Voyager was first launched. You remember running outside after playing some video games. You couldn't see properly because of the sun, and you freeze in your spot and have a eureka moment. You go through some notes taken in the past. The answer was in front of you all this time. Every now and then, the sun sends a burst of energy that causes the plasma of interstellar space to vibrate. Scientists can measure the frequency of waves when the plasma vibrates to show how close they are to each other. And on the day when the hum was delivered, there were some irregular frequencies coming from the sun. So that hum might have been the plasma vibrating in a weird way because of the sun flares. But these low-level vibrations last longer than quick jumps and spikes. They're fainter. You run the tests again and find out that it's not some intelligent life forms out there trying to talk to you. It's the little vibrations caused by sun flares. You notify your team about this breakthrough, and everyone's celebrating. But after all these tests and research, you still don't know why plasma in the interstellar medium vibrates in such a way. Those answers will have to wait. 2027. It's been 50 years since the launch of Voyager 1. You're way into your senior years and just retired from NASA. You have many scholarships in your name and programs for young people who want to learn about space and science. You go back to the control room once more, where you thought you had discovered intelligent life on a distant world. Then you remember all the good times you had. You say goodbye to everything, knowing that this is Voyager's final moments. It was built to last up to 50 years. After that, it'll just be a floating object in the vastness of space. It's already surprising to know that this is Earth's most distant object from us. But it's time to let others take your place. You shut off the lights and close the door. The Voyager makes one last beep before eternal silence.
AI can drive a car, design trendy clothes, give you emotional support, and it looks like it can also help us find answers to centuries-long mysteries. Researchers from Yamagata University Institute of Nazca and IBM Japan used a deep learning AI model to find new Nazca lines. Those are distinct white lines on a rusty red background that you can see from a plane while flying over the deserts of southern Peru. Scientists have tried to decipher the meaning of the Nazca lines ever since they were first discovered in the 1920s. There are straight lines, rectangles, triangles, and swirls. There are also some giant drawings. You can see a monkey, a whale, a condor, a hummingbird. The 4 recently discovered geoglyphs, which is the scientific word for those drawings, show a humanoid-like figure holding a club, a fish, a bird, and a pair of legs. What is the hidden symbolism of all that? And why did the Nazca people decide to draw a humanoid in the desert? And did they even know who humanoids were? Let's dig into history to find some answers. The representatives of the ancient Nazca culture created their famous lines more than 2,000 years ago. The geoglyphs have stood the test of time thanks to a dry climate and strong winds in the desert. Scientists found that to form the lines, the Nazca people scraped off the top layer of pebbles, revealing the contrasting soil beneath. The soil's color varies from reddish-brown to yellowish-gray. It makes it look like the lines are constantly changing appearance. It looks like the creators first made small-scale models and then enlarged them to create the full-scale designs we see today. In total, there are more than 800 straight lines, around 300 geometric figures, and 70 animals and plant designs. You can find the first mention of the lines in the 16th century Chronicle of Peru, where they were first described as trail markers in the desert. Since you can't really study the lines and their symbolism from the ground, those geoglyphs only became world famous only in the 1930s. It was the start of the era of commercial planes, so more and more people could witness the lines from their window seats and spread the word. During his research a decade later, Professor Paul Kosuk noticed that one of the lines aligned with the setting sun on the day after the winter solstice, which is the shortest day of the year. He supposed that the lines had some astronomical significance. German researcher Maria Reiche, who got the nickname the Lady of the Lines, supported the theory that the geoglyphs served as a calendar and some sort of astronomical purposes. She spent 40 years studying the lines and literally swept them inch by inch. She also moved into a small house close to the lines to protect them from unwanted visitors. And that's how the Nazca Lines mystery was solved. Just kidding. In the 1970s, American researchers began to question astronomical theory. In a region like Nazca, one of the driest places on Earth with only around 20 minutes of rain per year, water is a real treasure. So the straight lines and trapezoids could have something to do with it. They could have been an ancient version of Google Maps, pointing at locations for rituals that the local people organized to get some water and help their crops grow. The images of animals in the Andes region are also related to water. Spiders are thought to be a sign of rain. Hummingbirds symbolize fertility, and monkeys living in the Amazon mean an abundance of water. That could explain the choice of symbols in the desert, but there's no strong proof to support this theory. So the work on explaining the meaning of those mysterious geoglyphs is going on. In the 21st century, the Nazca Lines have become the research ground for archaeologists from Yamagata University. Masato Sakai, a professor of archaeology, together with others on the team, are using high-resolution aerial photography and drones to discover and catalog the lines. They found images of humans, camelids, birds, orca whales, cats, and snakes, most likely created between 100 before current era and 300 current era. Some of the images are around 10 to 20 feet long, and that's why they were pretty tricky to notice. The largest geoglyphs are 1,200 feet across, which is about the height of the Empire State Building. The researchers believe the Nazca lines were a form of communication in the desert for their creators. The linear ones pointed the direction from valley to valley. The ones drawn on slopes seem to have been drawn along ancient pathways between settlements. Professor Sakai explains that discovering new lines is tricky. Some of them are so poorly preserved that it's hard to spot them in aerial photos. There are also irrigation systems and roads all across the Nazca region, and it complicates the task. And that's where AI comes in handy. The team showed it pictures of previously explored Nazca lines so it could learn what to look for. Then, AI went through tons of footage taken from planes and satellites and also laser data from previous surveys to identify the lines scientists hadn't found before. The system works 21 times faster than humans, and it made some curious discoveries. Scientists then traveled to the locations it chose to verify the findings. In 2019, AI helped to discover a humanoid-shaped character with a rectangular head who is holding a stick and wearing a headdress. It became a real puzzle for the scientists trying to understand the creature's role in ancient society. The little guy is neighbors with another famous geoglyph. It's a hermit, which is a subgroup of hummingbirds that lives in the forested regions of northern and eastern Peru. The largest of the recently found geoglyphs is a pair of legs. It's more than 250 feet across, about 4/5 as tall as Big Ben. Could be an homage to some ancient supermodel. The fish and the bird are around 4 times smaller. Why they are where they are is still a mystery. Listing new geoglyphs isn't the only way AI is helping scientists. It's doing a lot of good for astronomy. It analyzes vast amounts of astronomical data and uses its algorithms to identify patterns, classify celestial objects, and even predict new events. For example, AI models have been developed to detect and categorize galaxies, search for exoplanets, and identify rare cosmic phenomena. It also helped analyze data obtained by the Kepler mission to discover new Earth-sized planets circling other stars. AI is also transforming the field of chemistry. Machine learning algorithms can predict chemical reactions, discover new compounds, and optimize chemical processes. All of this helps scientists save a lot of time and resources in the labs. If you've ever written a thesis, you know that analyzing vast chunks of information can take forever. Now imagine you need to analyze the archives of the British Library's national newspaper. It's piles and piles of history. So, researchers are teaming up with the curators to develop special software that can analyze the vast amounts of data extracted from these collections. Computational linguists and historians will be able to delve deep into the past and get some insights into changes in society and culture. They'll focus on key periods and track how advancements in technology shaped various aspects of society. AI even helps in the conservation of seals. It's really expensive and challenging to monitor certain species of those cutie pies living in the sea ice zone. Using high-resolution satellites, researchers can now identify the seals in photos, which already helps. But manually counting seals across huge areas of ice is like putting together a jigsaw puzzle of a blue sky consisting of 1 million pieces. It takes a lot of patience, and different analysts come up with different results. Machine learning algorithms can be trained to recognize and distinguish seals in satellite imagery and count them automatically. Researchers can then use this accurate data to monitor seal populations over time and study their behavior and habitat more effectively.
In the icy wilderness of Antarctica, there was a peculiar rock. Amidst the vast, smooth, and snowy landscape, it stood alone like a dark smudge. This rock had been there for ages, untouched except for occasional snowfall. Roberta Score, a lab manager at NASA's Johnson Space Center, had spent countless hours in Antarctica searching for rocks just like this one. Antarctica was an unexpected treasure trove for these discoveries. These rocks were easy to spot against the blindingly white ice. Why was it so important? Because it wasn't just any rock. It was a meteorite that had fallen from space thousands of years ago. Roberta's rock, known as ALH 84001, was initially unimpressive. However, it turned out to be extraordinary. It was a piece of Mars. The rock's chemical composition perfectly matched the surface of the red planet. Turns out, it had been blasted off Mars during a colossal collision millions of years ago. It was wandering through space before landing on Earth. There, it had remained undisturbed for a very long time. Scientists at Johnson Space Center carefully examined this Martian visitor. Years later, physicists made a remarkable announcement. This meteorite contained tiny structures that looked just like living organisms found on Earth. NASA immediately shared this discovery with the world. We found fossilized evidence of life on Mars. However, as other scientists got their hands on the rock and conducted further studies, they began to doubt it. Yes, it was a fascinating piece of rock, but Martian chemistry might create similar structures without life being involved. So, unfortunately, it wasn't conclusive evidence. But all this debate raised a very important question. Would we recognize extraterrestrial life if we saw it? There are more than 200 different definitions of life in scientific literature. So, what should we be looking for? To figure out what makes something alive, scientists have come up with 3 important things that living things must have. First, living things need to store information about themselves. This information tells them how to work and what they're like. It's a bit like having a set of instructions for how they function. Second, they need to be able to interact with their environment and create reactions. These reactions help them get energy, move around, and respond to changes or dangers. Lastly, they must be able to make copies of themselves, reproducing, and making other things that are just like them. This ability is a big part of what makes something alive. The famous physicist Erwin Schrödinger was one of the first people to figure this out. He said that storing, using, and passing on information is super important for life. It's like a cycle. Information helps create reactions, and some of those reactions let living things make copies of themselves. On Earth, we see this in action. We humans, for example, have DNA to store our information. It helps us with our evolution. Thanks to all this, we can adapt to our surroundings over time. Nature sees that some traits are helpful for survival, so they stick around, while others get left behind. In other words, a way to define life is by saying that it's subject to this process called Darwinian evolution. But how did it happen that things capable of evolution appeared? And when did the very first life emerge in our universe? To find out the answer, let's go to the very beginning of everything. The beginning was the Big Bang. Right after it, there were no stars or galaxies. The universe started as a mostly even and empty place, with just a tiny bit denser than the rest. After the first second or so, first protons, neutrons, and electrons, among other particles, appeared. And just about a couple of minutes later, these protons and neutrons came together to make stable atomic cores. Then, everything was a superhot soup of particles for about 380,000 years. It was way too hot to form anything dense. The universe needed some time to chill. After it calmed down a bit, it let electrons join these cores, forming neutral atoms for the first time. Finally, some comfy temperatures. If we were there, we wouldn't have needed the sun to keep us warm. That cosmic background radiation would have been enough. Could life appear at this point? Probably not. In those early moments after the Big Bang, the universe had only hydrogen, helium, a tiny bit of lithium, and almost none of the other elements life needs. Life, as we know, requires things like water and organic compounds. So it wasn't about the temperatures, it was about the ingredients. Now, everything had to form over time from these atoms. To create something like a planet, which is much denser than the universe on average, It needed a lot of time and gravitational squeezing. Gravity is the real hero of this story. It changed the universe completely. Even though it started slow, it kept going and got stronger. Regions that were a bit denser could pull in more matter, and the denser they got, the more they attracted. The very first star should have formed around 50 to 100 million years after the Big Bang. These stars could become incredibly massive, hundreds or even 1,000 times bigger than our Sun. And when these stars formed, it didn't take long, maybe 1 or 2 million years, before they disappeared. Just for comparison, our own Sun is 4.6 billion years old and still going strong. When huge stars reach the end of their lives, something incredible happens. They transform helium into carbon, then carbon into oxygen, and oxygen into a bunch of other stuff all the way up the periodic table. Then the star's core collapses, causing a massive supernova. This huge BAM releases all these heavy elements into the universe. Hooray! Now the space is filled with something new. The universe acquires many cool things, including the ingredients needed for rocky planets and organic molecules. Each generation of stars gets even richer than the previous one. Yes to more elements. It means more rocky planets, more essential ingredients for life, and more chances for complex organic molecules to form. And now, when the universe was around 300 to 500 million years old, rocky planets were already popping up everywhere. Great. Can we have some life now? That depends on what we see as life. The recipe for life as we know it needs a special ingredient, carbon. Carbon is special because it can bond with other atoms in so many ways. It can connect with different shapes to build all sorts of amazing complex structures. It's carbon that helps us form things like DNA and proteins, which are the building blocks of living things. Now, while the universe made rocky planets relatively quickly, it took a bit longer to get enough carbon floating around. It appeared about 1 to 1.5 billion years after the Big Bang. As soon as it appeared, the universe finally had enough conditions to create life as we know it, which is why scientists are searching for planets around these oldest stars in the universe. These guys definitely had enough time for evolution. But just because you and me are made of carbon and other elements from exploded stars, doesn't mean that all life should be. Scientists are open to the idea of alternative biochemistries. There might be non-carbon-based life that we don't know about yet. For example, blobby beings made of silicon compounds. It's carbon's neighbor in the periodic table. So, when and where did life truly begin? Unfortunately, we don't know for sure yet. Most likely, the universe started preparing for life shortly after the first stars formed. And if all life is carbon-based only, then it should have appeared 1 to 1.5 billion years after the Big Bang. The universe is 13.8 billion years old. Looks like it had plenty of time to evolve lots of microorganisms. So even if we made a mistake, and the mysterious meteorite was just a piece of rock, we shouldn't give up. The search for extraterrestrial life continues, and who knows? Maybe in the future, we'll finally know the answers to all these important questions. Until then, stay tuned.
AI can drive a car, design trendy clothes, give you emotional support, and it looks like it can also help us find answers to centuries-long mysteries. Researchers from Yamagata University Institute of Nazca and IBM Japan used a deep learning AI model to find new Nazca lines. Those are distinct white lines on a rusty red background that you can see from a plane while flying over the deserts of southern Peru. Scientists have tried to decipher the meaning of the Nazca lines ever since they were first discovered in the 1920s. There are straight lines, rectangles, triangles, and swirls. There are also some giant drawings. You can see a monkey, a whale, a condor, a hummingbird. The 4 recently discovered geoglyphs, which is the scientific word for those drawings, show a humanoid-like figure holding a club, a fish, a bird, and a pair of legs. What is the hidden symbolism of all that? And why did the Nazca people decide to draw a humanoid in the desert? And did they even know who humanoids were? Let's dig into history to find some answers. The representatives of the ancient Nazca culture created their famous lines more than 2,000 years ago. The geoglyphs have stood the test of time thanks to a dry climate and strong winds in the desert. Scientists found that to form the lines, the Nazca people scraped off the top layer of pebbles, revealing the contrasting soil beneath. The soil's color varies from reddish-brown to yellowish-gray. It makes it look like the lines are constantly changing appearance. It looks like the creators first made small-scale models and then enlarged them to create the full-scale designs we see today. In total, there are more than 800 straight lines, around 300 geometric figures, and 70 animals and plant designs. You can find the first mention of the lines in the 16th century Chronicle of Peru, where they were first described as trail markers in the desert. Since you can't really study the lines and their symbolism from the ground, those geoglyphs only became world famous only in the 1930s. It was the start of the era of commercial planes, so more and more people could witness the lines from their window seats and spread the word. During his research a decade later, Professor Paul Kosuk noticed that one of the lines aligned with the setting sun on the day after the winter solstice, which is the shortest day of the year. He supposed that the lines had some astronomical significance. German researcher Maria Reiche, who got the nickname the Lady of the Lines, supported the theory that the geoglyphs served as a calendar and some sort of astronomical purposes. She spent 40 years studying the lines and literally swept them inch by inch. She also moved into a small house close to the lines to protect them from unwanted visitors. And that's how the Nazca Lines mystery was solved. Just kidding. In the 1970s, American researchers began to question astronomical theory. In a region like Nazca, one of the driest places on Earth with only around 20 minutes of rain per year, water is a real treasure. So the straight lines and trapezoids could have something to do with it. They could have been an ancient version of Google Maps, pointing at locations for rituals that the local people organized to get some water and help their crops grow. The images of animals in the Andes region are also related to water. Spiders are thought to be a sign of rain. Hummingbirds symbolize fertility, and monkeys living in the Amazon mean an abundance of water. That could explain the choice of symbols in the desert, but there's no strong proof to support this theory. So the work on explaining the meaning of those mysterious geoglyphs is going on. In the 21st century, the Nazca Lines have become the research ground for archaeologists from Yamagata University. Masato Sakai, a professor of archaeology, together with others on the team, are using high-resolution aerial photography and drones to discover and catalog the lines. They found images of humans, camelids, birds, orca whales, cats, and snakes, most likely created between 100 before current era and 300 current era. Some of the images are around 10 to 20 feet long, and that's why they were pretty tricky to notice. The largest geoglyphs are 1,200 feet across, which is about the height of the Empire State Building. The researchers believe the Nazca Lines were a form of communication in the desert for their creators. The linear ones pointed the direction from valley to valley. The ones drawn on slopes seem to have been drawn along ancient pathways between settlements. Professor Sakai explains that discovering new lines is tricky. Some of them are so poorly preserved that it's hard to spot them in aerial photos. There are also irrigation systems and roads all across the Nazca region, and it complicates the task. And that's where AI comes in handy. The team showed it pictures of previously explored Nazca Lines so it could learn what to look for. Then, AI went through tons of footage taken from planes and satellites and also laser data from previous surveys to identify the lines scientists hadn't found before. The system works 21 times faster than humans, and it made some curious discoveries. Scientists then traveled to the locations it chose to verify the findings. In 2019, AI helped to discover a humanoid-shaped character with a rectangular head who is holding a stick and wearing a headdress. It became a real puzzle for the scientists trying to understand the creature's role in ancient society. The little guy is neighbors with another famous geoglyph. It's a hermit, which is a subgroup of hummingbirds that lives in the forested regions of northern and eastern Peru. The largest of the recently found geoglyphs is a pair of legs. It's more than 250 feet across, about 4/5 as tall as Big Ben. Could be an homage to some ancient supermodel. The fish and the bird are around 4 times smaller. Why they are where they are is still a mystery. Listing new geoglyphs isn't the only way AI is helping scientists. It's doing a lot of good for astronomy. It analyzes vast amounts of astronomical data and uses its algorithms to identify patterns, classify celestial objects, and even predict new events. For example, AI models have been developed to detect and categorize galaxies, search for exoplanets, and identify rare cosmic phenomena. It also helped analyze data obtained by the Kepler mission to discover new Earth-sized planets circling other stars. AI is also transforming the field of chemistry. Machine learning algorithms can predict chemical reactions, discover new compounds, and optimize chemical processes. All of this helps scientists save a lot of time and resources in the labs. If you've ever written a thesis, you know that analyzing vast chunks of information can take forever. Now imagine you need to analyze the archives of the British Library's national newspaper. It's piles and piles of history. So, researchers are teaming up with the curators to develop special software that can analyze the vast amounts of data extracted from these collections. Computational linguists and historians will be able to delve deep into the past and get some insights into changes in society and culture. They'll focus on key periods and track how advancements in technology shaped various aspects of society. AI even helps in the conservation of seals. It's really expensive and challenging to monitor certain species of those cutie pies living in the sea ice zone. Using high-resolution satellites, researchers can now identify the seals in photos, which already helps. But manually counting seals across huge areas of ice is like putting together a jigsaw puzzle of a blue sky consisting of 1,000,000 pieces. It takes a lot of patience, and different analysts come up with different results. Machine learning algorithms can be trained to recognize and distinguish seals in satellite imagery and count them automatically. Researchers can then use this accurate data to monitor seal populations over time and study their behavior and habitat more.
It's September 1977. You're playing one of the first video game consoles released in North America. You step outside and see the whole neighborhood waiting for Voyager 1 to launch. It's a super sunny day, so you squint a little, trying to see what's happening. You live in the neighborhood right outside the launching station. You get yourself some food and watch the Voyager take off into space. You're so impressed, you decide to dedicate your career to working with NASA. 35 years later, you're now a senior official in NASA, specializing in Voyager 1. It's 2012, and you're sitting in the control room with your colleagues. Everyone is staring at their computer screens as they work on the Voyager. You're sitting on the top, overlooking everything and making sure all systems are in check. This day is special, as Voyager 1 is about to exit the heliosphere, which is a science word for the outer shell of our solar system. It's a bubble of space affected by the solar wind, which comes from the sun. By 2021, it got 14 billion miles away from Earth, which is equivalent to 153 astronomical units from the sun. 1 astronomical unit is the distance between the sun and the Earth. The craft was originally meant to fly by Uranus, Saturn, and Jupiter, and toss itself from one planet to another with the use of their gravitational pull. Everyone is impatiently waiting for it to exit the heliosphere. 3, 2, 1, and it's officially out. All systems are normal and functioning. You praise your team for doing an excellent job. With Voyager 1 reaching this far, there's still tons to explore in outer space. You were once a young adult watching the craft launch outside your neighborhood, and now you're the main person in charge of the operation. 9 years later. Since Voyager 1 left the heliosphere, you've been checking up on it every now and then, making sure all systems and functions are in order. It's been sending back measurements of the interstellar medium. It's the area between the stars of our galaxy, consisting of ionized materials. Ionized is basically a simple version of a molecule or substance. The interstellar medium is an electrically charged state of plasma, or ionized plasma, and is very unstable. It's like going from lightning in a thunderstorm back to calm rain in a matter of seconds. The plasma up there is different than the plasma on Earth, in that it's difficult to filter out. There are around 0.06 atoms for every cubic inch in the interstellar medium. The air we breathe on Earth has billions of atoms. By measuring the plasma in the interstellar medium, we can further understand the behavior and structure of chemicals and gases. It's possible that the oxygen we know and love on Earth is different than the ones out there. One of your main tasks is to learn more about how the solar wind from the sun and interstellar medium interact with each other to create the heliosphere. So, after doing some routine checkups and other maintenance work on Voyager 1 from the control room, you notice something strange coming from the screen. You sit in front of the computer, crunching the numbers of the plasma vibrations and convert them into an audio file of about 3 kilohertz. You click on it and listen to an eerie, subtle hum. You and your team are surprised that these vibrations occurred in such a small frequency. Given that space is massive, something like this might mean life on other planets. Everyone else at the station rushes to the control room to listen to that sound from outer space. It's monotonous and faint, but it's definitely coming from outside the heliosphere. You run the numbers over and over to make sure it's not a fluke, but it's on point. You make sure your team doesn't spill the beans to anyone outside until everything is known and clear. You get into beast mode with work and try to catch the sound again, and it remains. You can't sleep trying to think of something that could be producing this hum. A few days pass by, and the sound is pretty consistent. If there was some life out there trying to communicate with you, then surely it would have said something that can be deciphered. You analyze the audio files once again, trying to see if it's some phonetic language you don't know. You call in a linguist to see if she can make something out of it. You and the squad gather around, waiting impatiently for some answers. After a while, she believes that it might be someone out there communicating with us, but the only way to find out is by sending something back to them. You arrange a meeting with your team and try to figure out what message you can send. After much thinking and lots of coffee, you decide to send them one phrase in English. Who are you? You send out the signal through Voyager 1 and wait for any changes in the hum, but you don't get anything straight away. It may take some time for a response. You wait all night, and still, there's nothing. It's starting to look like there isn't anything out there. For the next couple of days, you keep sending out phrases for anything to pick up. Since space is a vacuum, sound waves can't travel, so sending out voice messages on a large speaker won't work. You locate the source of the humming and aim for it when sending the audio file. Every day, you send something different, but still, you don't hear anything from them for a week. It seems that intelligent life in the distant world isn't real. The areas between the star systems in a galaxy aren't necessarily a complete vacuum. That's where the interstellar medium is. It contains gases, dust, and cosmic rays, which are energy particles. After many months of this constant humming being produced, you still try to figure out what's going on. You sit there, remembering the time when the Voyager was first launched. You remember running outside after playing some video games. You couldn't see properly because of the sun, and you freeze in your spot and have a eureka moment. You go through some notes taken in the past. The answer was in front of you all this time. Every now and then, the sun sends a burst of energy that causes the plasma of interstellar space to vibrate. Scientists can measure the frequency of waves when the plasma vibrates to show how close they are to each other. And on the day when the hum was delivered, there were some irregular frequencies coming from the sun. So that hum might have been the plasma vibrating in a weird way because of the sun flares. But these low-level vibrations last longer than quick jumps and spikes. They're fainter. You run the tests again and find out that it's not some intelligent life forms out there trying to talk to you. It's the little vibrations caused by sun flares. You notify your team about this breakthrough, and everyone's celebrating. But after all these tests and research, you still don't know why plasma in the interstellar medium vibrates in such a way. Those answers will have to wait. 2027. It's been 50 years since the launch of Voyager 1. You're way into your senior years and just retired from NASA. You have many scholarships in your name and programs for young people who want to learn about space and science. You go back to the control room once more, where you thought you had discovered intelligent life on a distant world. Then you remember all the good times you had. You say goodbye to everything, knowing that this is Voyager's final moments. It was built to last up to 50 years. After that, it'll just be a floating object in the vastness of space. It's already surprising to know that this is Earth's most distant object from us. But it's time to let others take your place. You shut off the lights and close the door. The Voyager makes one last beep before eternal silence.
Are we really by ourselves in the universe? It's a daunting question that's been haunting us for centuries. No wonder scientists have tried to come up with all sorts of ideas as to why. One of the strangest theories concerning our lack of contact with other life forms is named the dark forest theory. Let's start small. Well, sort of. We'll focus on our Milky Way for now to better understand this theory. Our cosmic neighborhood is a galactic wonderland, sprinkled with 200 billion twinkling stars and maybe around 100 billion planets. So let's get hypothetical for a moment and say a tiny part of those habitats hosts life. Further, out of those life-bearing planets, a few might have evolved into intelligent beings. Given that, you'd think we'd be knee-deep in weird-looking neighbors, some of whom might be actively trying to find us or might just be out there, waiting to be discovered. Now, let's put a little science into this science fiction scenario. We have something called the Drake equation, which is a kind of universal roll call that estimates how many smart civilizations could pop up in our galaxy. You can think of this equation as the super smart roadmap. By playing around with a few important factors, the equation hints that there should be around 20 civilizations just in our galactic backyard. So why haven't we stumbled upon any yet? This theory isn't an easy task. It's a mixed bag of multiple variables, like the average number of planets per solar system that could potentially host life, or the rate at which stars suitable for intelligent life are formed. A tricky part here is that astronomers have yet to solidify the exact values of these variables, which means our calculations are just approximations for now. But back to the Milky Way, shall we? Feed in our hypothetical assumptions, crunch the numbers, and you get at least 20 civilizations. Yet somehow, our cosmic switchboard remains weirdly silent. How come? This radio silence has its own name, too, the Fermi paradox, named after the guy who first thought, "Hey, where is everybody?" over 50 years ago. Since then, we've had a lot of different theories trying to solve this mystery, all tinkering with different aspects of the Drake equation. Some folks think the appearance of life is a rare event. Others think that getting from bacteria to advanced beings is the tricky part. Yet, some reckon that civilizations might either wipe themselves out after a short lifespan or never even get to invent something they could communicate with. But there's one theory that tops all others in its creepiness: the dark forest theory. According to it, the universe is a huge cosmic version of a haunted forest. And other types of creatures are out there, playing a game of hide and seek. They're intentionally keeping silent. Why? Well, the dark forest theory was best explained in a sci-fi novel. And the rationale goes something like this. For starters, every life form wants to stay alive. I'll buy that. If we go with that assumption, it's impossible to be sure whether other life forms might harm you if they get the chance. So, the safest bet is to take them out before they find the right time to do the same to you. Frankly speaking, it's the universe's version of the survival of the fittest. In this scenario, making contact with others becomes the most dangerous game, as it could lead to your location being traced and you being wiped out. How human. This results in everyone keeping quiet, a kind of universal shush, where every civilization tries to hide in utter cosmic silence. But hey, is this just an idea good for a thrilling novel, or does it have some real-world implications? Well, the theory was suggested by scientist David Brin as a possible explanation for the lack of radio evidence for non-Earth-like life. He went as far as imagining it would be robots that would do the dirty work of wiping out civilizations. But how realistic is this theory anyway? Well, it doesn't require us to assume a lot of stuff about the behavior of all foreign civilizations. Just one advanced race behaving this way could explain our observed reality. And it might explain why we've not picked up any advanced radio chatter despite a century of eavesdropping. It's possible that other creatures like us are too terrified of being noticed and have gone radio silent on purpose. But, and it's a big but, like mine, it does base itself on the notion that other species share our level of risk aversion and logic, or that there's a rogue civilization out there picking off anyone they perceive as a threat. And that's a pretty significant assumption. If that doesn't sound creepy, this next piece of information certainly will. For about a century now, we've been shouting our existence into the cosmos. If this theory proves to be correct, every other civilization within 100 light-years of us might be getting our signals and knowing exactly where we are. And if we have reasons to hide from them, as suggested by some like Stephen Hawking, we might already be in trouble. But what if this theory isn't true? What if, sooner than we'd like to imagine, weird galactic creatures will indeed try to reach us? The truth is, most of us wouldn't even know what to do. Hey, let's not get over ourselves. In fact, some scientists are tackling this issue head-on. For the first time since the 1980s, specialists are trying to cook up a how-to guide for when we inevitably bump into cosmic neighbors. For instance, some researchers believe we've got to do more than just worry about how these life forms could shake up our world. If they send any type of radio signals down here, we've got to think about our reply. What are we going to say? Hey, we're humans. Nice to meet you. Absolutely not. We've got to do better than that. See, the only plan we've had till now came from a rough blueprint dating from 1989. This guide is a bit wishy-washy on what to do when the entire world gets the outer worldly text. Mostly it says, hey, let's share the news with everyone. But then what? If we confirm it's legit, officials will need to ask the United Nations for advice. But hey, does the United Nations even have a plan? Maybe, who knows? We've been doing loads of space exploring lately. Some say we've stumbled upon water on Mars. Others are sure we've spotted some planets that could be twins to Earth. So the idea of finding life elsewhere isn't that far-fetched. But even after 100 years of trying to chat with cosmic beings, it's still a one-sided conversation. This new protocol isn't just about chatting up outsiders. It's also going to act as our cosmic voicemail, checking messages from outer space. It aims not just to decode the external lingo. It's also planning to figure out what these messages could mean for us. The plan is also to draft reports about how different policies could impact us and set up guidelines on how to respond to these space texts. So, will we ever get a message from our cosmic mates? Only time will tell. But what we do know is that we just can't wing it. We can't be caught off guard and start a planet-wide frenzy when we get that otherworldly WhatsApp. We gotta have a plan, and we gotta have it ready for when we're face-to-face with the real deal. I mean, we've come across a lot of potential such sightings, but none of them proved to be genuine. On that note, U.S. authorities checked over 100 cases of weird stuff going on in the skies. I'll spare you the details, but not one green creature was ever found. More like drones and similar stuff floating around. So, as we stand on the cusp of this potentially game-changing event, we must strive to be prepared. Whether our intergalactic neighbors drop us a text tomorrow or centuries from now, we need a plan. After all, this could change everything we know about our universe and our place within it. In the icy wilderness of Antarctica, there was a peculiar rock. Amidst the vast, smooth, and snowy landscape, it stood alone, like a dark smudge. This rock had been there for ages, untouched except for occasional snowfall. Roberta Score, a lab manager at NASA's Johnson Space Center, had spent countless hours in Antarctica searching for rocks just like this one. Antarctica was an unexpected treasure trove for these discoveries. These rocks were easy to spot against the blindingly white ice. Why was it so important? Because it wasn't just any rock. It was a meteorite that had fallen from space thousands of years ago. Roberta's rock, known as ALH 84001, was initially unimpressive. However, it turned out to be extraordinary. It was a piece of Mars. The rock's chemical composition perfectly matched the surface of the red planet. Turns out, it had been blasted off Mars during a colossal collision millions of years ago. It was wandering through space before landing on Earth. There, it had remained undisturbed for a very long time. Scientists at Johnson Space Center carefully examined this Martian visitor. Years later, physicists made a remarkable announcement. This meteorite contained tiny structures that looked just like living organisms found on Earth. NASA immediately shared this discovery with the world. We found fossilized evidence of life on Mars. However, as other scientists got their hands on the rock and conducted further studies, they began to doubt it. Yes, it was a fascinating piece of rock, but Martian chemistry might create similar structures without life being involved. So, unfortunately, it wasn't conclusive evidence. But all this debate raised a very important question. Would we recognize extraterrestrial life if we saw it? There are more than 200 different definitions of life in scientific literature. So, what should we be looking for? To figure out what makes something alive, scientists have come up with 3 important things that living things must have. First, living things need to store information about themselves. This information tells them how to work and what they're like. It's a bit like having a set of instructions for how they function. Second, they need to be able to interact with their environment and create reactions. These reactions help them get energy, move around, and respond to changes or dangers. Lastly, they must be able to make copies of themselves, reproducing, and making other things that are just like them. This ability is a big part of what makes something alive. The famous physicist Erwin Schrödinger was one of the first people to figure this out. He said that storing, using, and passing on information is super important for life. It's like a cycle. Information helps create reactions, and some of those reactions let living things make copies of themselves. On Earth, we see this in action. We humans, for example, have DNA to store our information. It helps us with our evolution. Thanks to all this, we can adapt to our surroundings over time. Nature sees that some traits are helpful for survival, so they stick around, while others get left behind. In other words, a way to define life is by saying that it's subject to this process called Darwinian evolution. But how did it happen that things capable of evolution appeared? And when did the very first life emerge in our universe? To find out the answer, let's go to the very beginning of everything. The beginning was the Big Bang. Right after it, there were no stars or galaxies. The universe started as a mostly even and empty place, with just a tiny bit denser than the rest. After the first second or so, first protons, neutrons, and electrons, among other particles, appeared. And just about a couple of minutes later, these protons and neutrons came together to make stable atomic cores. Then everything was a super hot soup of particles for about 380,000 years. It was way too hot to form anything dense. The universe needed some time to chill. After it calmed down a bit, it let electrons join these cores, forming neutral atoms for the first time. Finally, some comfy temperatures. If we were there, we wouldn't have needed the sun to keep us warm. That cosmic background radiation would have been enough. Could life appear at this point? Probably not. In those early moments after the Big Bang, the universe had only hydrogen, helium, a tiny bit of lithium, and almost none of the other elements life needs. Life, as we know, requires things like water and organic compounds. So it wasn't about the temperatures, it was about the ingredients. Now, everything had to form over time from these atoms. To create something like a planet, which is much denser than the universe on average, it needed a lot of time and gravitational squeezing. Gravity is the real hero of this story. It changed the universe completely. Even though it started slow, it kept going and got stronger. Regions that were a bit denser could pull in more matter, and the denser they got, the more they attracted. The very first star should have formed around 50 to 100 million years after the Big Bang. These stars could become incredibly massive, hundreds or even 1,000 times bigger than our Sun. And when these stars formed, it didn't take long, maybe 1 or 2 million years, before they disappeared. Just for comparison, our own Sun is 4.6 billion years old and still going strong. When huge stars reach the end of their lives, something incredible happens. They transform helium into carbon, then carbon into oxygen, and oxygen into a bunch of other stuff all the way up the periodic table. Then the star's core collapses, causing a massive supernova. This huge BAM releases all these heavy elements into the universe. Hooray! Now the space is filled with something new. The universe acquires many cool things, including the ingredients needed for rocky planets and organic molecules. Each generation of stars gets even richer than the previous one. Yes to more elements. It means more rocky planets, more essential ingredients for life, and more chances for complex organic molecules to form. And now, when the universe was around 300 to 500 million years old, rocky planets were already popping up everywhere. Great. Can we have some life now? That depends on what we see as life. The recipe for life, as we know it, needs a special ingredient, carbon. Carbon is special because it can bond with other atoms in so many ways. It can connect with different shapes to build all sorts of amazing complex structures. It's carbon that helps us form things like DNA and proteins, which are the building blocks of living things. Now, while the universe made rocky planets relatively quickly, it took a bit longer to get enough carbon floating around. It appeared about 1 to 1.5 billion years after the Big Bang. As soon as it appeared, the universe finally had enough conditions to create life as we know it, which is why scientists are searching for planets around these oldest stars in the universe. These guys definitely had enough time for evolution. But just because you and me are made of carbon and other elements from exploded stars, doesn't mean that all life should be. Scientists are open to the idea of alternative biochemistries. There might be non-carbon-based life that we don't know about yet. For example, blobby beings made of silicon compounds. It's carbon's neighbor in the periodic table. So, when and where did life truly begin? Unfortunately, we don't know for sure yet. Most likely, the universe started preparing for life shortly after the first stars formed. And if all life is carbon-based only, then it should have appeared 1 to 1.5 billion years after the Big Bang. The universe is 13.8 billion years old. Looks like it had plenty of time to evolve lots of microorganisms. So even if we made a mistake, and the mysterious meteorite was just a piece of rock, we shouldn't give up. The search for extraterrestrial life continues, and who knows? Maybe in the future, we'll finally know the answers to all these important questions. Until then, stay tuned. It's normal for planets to be a bit tilted on the side. The Earth is tilted at a 23-degree angle. That's why we have seasons. It's summer when the part of the world where you are leans closer to the sun. It works the opposite way too. It's winter when you lean away from it. But Uranus is tilted more than normal. It lies as a 98-degree angle, which has a huge effect on its seasons. Each season on Uranus takes 21 years to play out. Something to think about the next time we complain that winter lasts forever. Now, here on Earth, we measure distances in minutes and hours, maybe even days. It takes 10 minutes to walk to your best friend's house, or 15 minutes to drive to your favorite cafe. But in space, it's different. It's vast, which means we measure how long it takes to get to a certain point in years, or in most cases, light years. So, if you want to walk to the moon one day, that would take you 9 years to span the 239,000 miles. Perhaps you'd like to take a ride to the nearby star, Proxima Centauri. Maybe if you kept the pedal to the metal at a constant speed of 70 miles per hour, you'd get there in about 356 billion hours, or around 40.5 million years. Trust me, after the first 20 million years, you'd be second-guessing yourself as to why go there in the first place. Now, Mars contains the biggest valley, Valles Marineris, we've discovered so far. It's a pretty impressive system of canyons, 2,500 miles long. That's 5 times longer than the Grand Canyon. Researchers first spotted it back in the 1970s. A bank of volcanoes located on the other side of the canyon ridge probably helped form this valley. We haven't discovered a planet completely made of diamonds yet, but on some planets, it actually rains diamonds. On Jupiter and Saturn, gas giants of our solar system, lightning storms turn abundant methane into soot, which we also know as carbon. The soot falls and transforms into graphite. Further graphite transforms into diamonds with a diameter of about 0.4 inches. Now, before you start figuring out how to book a diamond collecting field trip, know that these diamonds don't last. After they enter the planet's core, they melt. Ever notice how when you're stargazing 2 nights in a row in the same time, let's say 9 p.m., the stars stay in the same place, but the moon doesn't? Well, there are 2 reasons for that. First, it depends on what time you go stargazing. For instance, if you go outside at 8 p.m. and tomorrow you look for it at 11 p.m., you'll see the moon in 2 pretty different places. In this case, even the stars take different places in the sky since our planet is spinning. As you know, it takes 24 hours for it to make one full circle. That means, from our point of view, it seems like both the sky and everything up there is just moving around us one time per 24 hours. In the same way, the sun changes its position, rising and setting every day. So, if you went outside 2 nights in a row at the same hour, in most cases, you'll have to wait for an extra half hour or more until the moon gets back to the same position as the night before. The stars are pretty much standing still. It seems like they're moving, but that's because the Earth is spinning. But the moon is actually moving around our planet and goes through different phases. For example, a new moon is when it's completely dark in the sky. A full moon is when its day side is facing the Earth. It takes approximately a month for it to finish one circle around the Earth. Maybe you'd be luckier on a diamond collecting expedition on this next planet, 40 million light-years away from Earth. Scientists used to call it a super-Earth. Now, a super-Earth is generally a planet way bigger than ours. This planet, for example, is double the Earth's size. It's so close to its star that it makes a full circle around it in less than 18 hours, which means a year there is pretty short. Since it's so close to its star, its temperature goes up a whopping 4,900 degrees Fahrenheit. Because of the heat, in combination with the planet's density, scientists have the theory that its core is made of carbon in the form of graphite and diamonds. Over 10 years ago, astronomers discovered a huge water vapor cloud. It was 12 billion light-years from our home planet. That cloud is the biggest source of water we know of. It's also the oldest, dating back to when the universe was only 1.6 billion years old. Now it's 13.8 billion years old. Man, if only I had started a savings account 12 billion years ago. With compound interest, I'd have me quite a pile of cash by now, but I wasn't around then. Anyway, this cloud is so large it holds 140 trillion times the amount of water in all the oceans on our planet. This cloud kind of feeds a black hole. It may also contain enough gases, such as carbon monoxide, to encourage the black hole to grow 6 times bigger than it is at the moment. The average temperature of our planet is about 57 degrees Fahrenheit, and the highest temperature ever measured was 134 degrees. Sound too hot? Well, on Venus, it can go up to 900 degrees, which makes it the hottest planet in our solar system. It's not hot enough to melt steel, though. It would need to be higher by 2,500 degrees to get there. But it's hot enough to melt lead, and it's way too hot to sustain life, at least not in any form that we know. Venus is not even the closest to the Sun, it's Mercury, but it has a super thick atmosphere that traps greenhouse gases. It's like you covering yourself with a pretty thick blanket in the middle of the summer. Now, we're used to seeing volcanoes spewing hot molten lava. After all, that's what they mostly do on Earth. But in space, volcanoes tend to spew methane, water, or ammonia. And these materials freeze as they erupt and eventually transform into frozen vapor and something called volcanic snow. I'm talking about cryovolcanoes here. You can find them on Jupiter's moons Io and Europa, Saturn's moon Titan, and Pluto. These volcanoes are especially active on Io, which has hundreds of vents. NASA vehicles have even captured some of these erupting in real time. Plumes of frozen vapor coming out of them extended for about 250 miles. Hey, by the way, they just discovered another moon around Jupiter that might actually be good for farming someday. It's named EIEIO. Now, what exactly happens to the light after it disappears inside of a black hole? Well, photon is a particle of light. The event horizon is the boundary of a black hole. When something, say a photon, crosses the line and enters those boundaries, it can't escape anymore. But it doesn't mean a black hole destroyed it. It pulls the photon in rapidly towards its center, where an enormous mass is packed into an infinitely small space. But we're not sure what happens to photons in such extreme conditions. It's still one of the biggest mysteries. Does a black hole destroy the light or not? Saturn has 82 moons we know about, 53 confirmed and 29 more that are still on the waiting list to be confirmed as actual moons before they get their official names. And one of the coolest moons might be a 914-mile-wide hunk of rock called Iapetus. It's dark on one side and bright on the other. Its lighter half is 20 times more reflective than the other one. As it turned out, the bright side is ice. The dark side is a bit more complicated. One theory says it's dark because of particles coming from another moon, the one named Phoebe. Another theory says it could be because of heat. Since the moon is rotating really slowly, its dark material is absorbing heat, which makes it even darker. Now, how big do you think a black hole can become? In theory, we can't find an upper limit to its mass, but astronomers believe the ultramassive black holes, or UMBHs, located in the cores of certain galaxies are mostly up to 10 billion solar masses big. Recently, they even discovered these UMBHs physically can't grow much more than this, because, in that case, they would start to disrupt the accretion disks that feed them. That way, they would kind of stuff the source of new material. Most people picture the universe as somewhere between aquamarine and pale turquoise. Even some researchers thought that was the case. They managed to determine the cosmic color by combining light from more than 200,000 galaxies within 2 billion light-years of our planet. But the real color is actually closer to beige. Researchers got it all wrong because there was a bug in the software. No, really? It converted the cosmic spectrum into the color our eyes would see if we were exposed to it. The team defined this color as a cosmic latte. Ooh, make that a double-shot low-fat large to go, please.
84 million years ago. Many modern mammals, birds, insect groups, even the first flowering plants are already there. Dinosaurs are still roaming around. They have around 20 million years left before the asteroid. T-Rex, a fearless hunter, becomes the king of the dinosaurs. And the Earth tilted by 12 degrees. Picture our planet as a chocolate truffle. The shell is hardened, the center is viscous, with semi-solid matter. Its top layer, the crust, consists of tectonic plates that are like puzzles. Continents and oceans come on top of these plates. 84 million years ago, the mantle and the crust started rotating around our planet's outer core, then going back. If you'd been able to see it from space, it would have seemed like the entire planet has tipped over on one side. Today, it would have moved New York City to where Florida is. Let's say our planet is like a spinning top. It whirls perfectly if the weight on the top is evenly distributed. But if you move some of the weight to one side, it makes it tilt. It may have been caused by the moving of the tectonic plates and one of them sinking under another. We might be drinking water older than our solar system. Some scientists think the water we have on Earth may have come from ice specks that were floating in some sort of a space cloud more than 4.5 billion years ago. Lakes aren't always peaceful and relaxing. They can also explode. It happens when there are volcanic gases under the surface that can burst, rise to the surface, and cause big damage. The Earth's rotation is slowly going through time. Every year, the moon gets a little bit of energy from our planet and slowly drifts farther away from it. These two things are making our day longer, but really slowly, around 1.4 milliseconds every 100 years. That means when dinosaurs were around, the day was 23 hours long. Our planet used to be purple. One theory says ancient microbes didn't rely on chlorophyll to absorb the sun, but on different molecules. They absorbed green light and then reflected back a nice purple color. Every time you take a dip in the ocean, remember you're swimming above more than $700 trillion worth of gold. Not on the ocean floor waiting for someone to get it out, but in tiny particles dispersed in the water. The deepest place on our planet is the Mariana Trench, a spot in the Pacific Ocean, 36,201 feet under sea level. But the deepest place that's not covered in the ocean is in Antarctica. Technically, it's hidden below thick and deep layers of ice, goes more than 8,300 feet below sea level. There are 60 tons of dust falling from space to our planet every day. You probably inhale a pretty good amount of this cosmic dust while just going to work. It's dust, small particles from comets, meteorites, and some other space bodies. Dalal, Ethiopia, is the hottest inhabited place on our planet. Between 1960 and 1966, the temperature was 106 degrees Fahrenheit, and even in the wintertime, the temperature goes up to 98 degrees Fahrenheit on average. 8 minutes and 20 seconds. That's the time sunlight needs to travel from the sun to our planet. It's still not that much compared to what it takes for the light to reach Pluto, 5.5 hours. Almost 70% of the fresh water we have in this world is held in ice sheets and glaciers. More than 96% of the total amount of water on Earth is in the oceans. The Earth is like some sort of big magnet. Its inner core is actually a sphere made of solid iron, with liquid iron surrounding it. All those variations and changes in density and temperature create some sort of force, which makes the iron produce electrical currents. They are lined up by the planet's spin, and together, they create a magnetic field. There are many stars in the Milky Way, 100 billion, but way more trees on our planet alone, around 3 trillion. You can tell how old the tree you're looking at is by its rings. They can also tell you more about the conditions of a given year, too. When these rings are thin, there was a drought, while the thick ones say it was a rainy period. Earth is a magical planet where even rocks can walk, at least some of them, in Death Valley, California. They leave trails so you can record the path they've passed. Some of those biggest rocks have left tracks behind up to 1,500 feet long. Smooth-bottomed rocks wander around, while those with rough surfaces tend to leave straight tracks. The world that surrounds us consists of atoms, and they seem to be solid. But 99.99% of them are just empty space. An atom is just a really small nucleus and a cloud of electrons surrounding it. These electrons are particles, but they act like waves. They don't exist in one point but are spread over a range of probabilities and occupy lots of space. Take the empty space in our atoms, and all the humans could fit in a really tight space like the volume of a sugar cube. Australia is slowly shifting north, 2.75 inches per year because of tectonic movements. Australia is one of the top continental tectonic plates that move faster than others. You'd need 400,000 moons to reach the level of brightness the sun has. Sounds a lot at first, but the moon only reflects the light coming from the sun. It doesn't make its own. And even though that's not enough, its brightness depends on the exact angle between the sun, moon, and the Earth. The planet we live on used to have 2 moons, or at least some scientists believe so. They figure the side of the moon that faces the Earth is relatively flat and low, while the other side is way thicker and crustier. The theory says that there used to be the second moon that collided with the thicker side. Some believe there's still a second moon. It could be not a giant space body we see clearly in the sky, but some sort of a small asteroid pulled into the Earth's orbit. Air doesn't mostly consist of oxygen. Almost 78% of it is nitrogen. If you want to see some pretty steep rocks, go to Canada, Auyuituk National Park. It has the biggest vertical drop in Canada, the tallest and the steepest cliff, with 105 degrees of overhang and 4,000 feet of rock. A team of 4 American men finally made it to the top in 1985, although there were 30 attempts for that before. It took them 33 days to get up. The Pacific, Atlantic, Indian, and Arctic are the 4 world's oceans. The 5th is confirmed to be the Southern Ocean. It's not defined by the continents around it, but by its Antarctic current that goes from west to east. Research shows this current was created more than 30 million years ago when South America and Antarctica had separated. This allowed water to flow around the bottom of the ocean without any barriers. Melting glaciers and ice sheets means more water in the oceans. It adds the extra weight of all that liquid pressing down the sea bottom, making it sink. The Earth's surface looks solid and kinda permanent, but every 500 million years, it goes through a process of regeneration. Tectonic plates crash into each other. Continental crust creates pressure on the oceanic crust, and that pressure activates the volcanoes. Through time, all this results in regenerating and replacing a majority of the Earth's surface, just like our body regenerates skin cells, replacing old with new ones. Out of all planets in the solar system, Earth is the only one with the outer crust that's broken up into huge surfaces we call tectonic plates. This is an important process that allows the formation of oceanic trenches and mountains, and also helps with protecting the Earth. When microscopic planets that live in the ocean are gone, they fall down to the bottom. The remnants go back into the interior of our planet and get recycled, and eventually end up in the atmosphere, protecting us from overheating and turning into Venus, the hottest planet in our solar system.
From the tiniest ants to the mightiest galaxies, why do things work the way they do? If we imagine the universe as a giant puzzle, we already found some important pieces: electromagnetism, gravity, tiny particles, and so on. But even with all this, we can't get the full picture. We still can't figure out how everything works. What we're trying to find is the theory of everything. This is the mysterious theory that should be able to fit everything in our world together. For years, brilliant minds like Isaac Newton, Albert Einstein, Niels Bohr, and many others tried to derive this theory. But as you can imagine, it's not a simple task. Albert Einstein was one of the first to get very close to the answer. He spent his entire life watching and analyzing the world. As a result, he came up with his most famous equation: E equals mc squared. This equation tells us how energy and mass are connected. Energy can turn into matter and vice versa. But that's not enough, so he created his theories of relativity. One was called special gravity. It says nothing can go faster than light, and time can stretch or shrink depending on how fast you're moving. Then, he combined it with general relativity, which introduced gravity into the equation. He thought of gravity as the universe's way of bending space and time. Just like a fabric stretches when you place a heavy ball on it, space-time stretches when we place things like planets in it. This effect is what we call gravity. Einstein also wanted to connect gravity with the other forces, like electricity and magnetism. That way, everything could be together in harmony, and there were scientists who decided to help him with that. Their names were Theodore Kaluza and Oskar Klein. In the 1920s, they decided that it would be cool to add extra dimensions to our universe. Electromagnetism explained how electricity and magnetism work together. And now, Einstein, Kaluza, and Klein wanted to add relativity to it, like mixing several flavors of ice cream to create a super delicious universe sundae. To make this wild idea work, Kaluza and Klein had to add a whole new dimension to our world. We usually think of our world as having 3 dimensions, like length, width, and height, plus time. But these scientists created the 5th dimension, although it's all tiny and hidden, so you couldn't spot it in your everyday life. All this gave us a more or less full picture of the world. Many even thought that Einstein did it, found the theory of everything. But if only things were that simple. Unfortunately, even though Einstein was a genius, he couldn't unite everything. You know what screwed things up for him? Quantum mechanics. Quantum world turned out to be insane. When we looked at the particles, we learned that they could do magical tricks. For example, they could be in two places at once, or disappear and reappear again out of nowhere. Einstein couldn't explain that. He wanted things to be logical and predictable, like knowing exactly where a particle is and how fast it's going. But quantum mechanics showed that our world is much more complicated, weird, and random than what we thought. But even though Einstein didn't explain absolutely everything, his legacy still lives on. Today, scientists are picking up where he left off. So how close have we gotten to the theory of everything since then? Well, quantum mechanics tried to nominate its candidate, string theory. This hero emerged in the 1980s. Quantum physics pals had a wild idea. What if the tiniest bits of everything in our world weren't particles, but super tiny strings? Yeah, like guitar strings. Almost. They look like little dots to us, which is why we see them as tiny particles. But if we looked at them under the best microscope ever, they would look like little loops. In that case, everything in the universe is made up of these little vibrating strings. Just like different notes on a guitar string make different sounds, these tiny strings can vibrate in different ways. And each way they vibrate creates a different particle. One note might give us a particle we call an electron. Another vibration could be a particle like a photon, and so on. But there is another cool idea that string theory suggests. It suggests that our universe has more than just the usual 3 dimensions we can see, like up, down, left, right, and forward and backwards. What if there are extra hidden dimensions that these strings can wiggle in? And theorists say that they might be up to 10 or even 11 of these dimensions. At first, everyone thought that this was it. This could be the theory of everything. But, just like in the movies, when everyone thinks that they've defeated the villain, more problems pop up. String theory didn't fit the universe's rules discovered by Einstein. This is the last piece of the puzzle they've been trying to find for many years. If string theory supporters figure out how to connect their ideas with Einstein's theories of relativity, they'll finally be able to explain all the things ever. And they made some attempts. String theory began to divide into many branches. For example, it gave rise to the multiverse theory. Alright, we know that all the tiny strings can vibrate and wrap in different ways. There are many ways for each string to vibrate. The combination of their vibrations give many possible results. And there are trillions upon trillions of these strings. And just like one musical note can help to create different harmonics and songs, strings can create different versions of the universe. Each version might represent a universe with its own set of physical laws and properties. You probably heard about the parallel worlds. Well, it's a real scientific concept. The multiverse theory says that our world isn't the only one. There's an infinite number of universes and their number is constantly growing. Let's say you're baking cookies. In one universe, you make chocolate chip cookies. In another universe, you make oatmeal raisin cookies. And yet, in another universe, you make them with peanut butter. Even for such a small decision, there are a lot of parallel worlds. Something like this is very hard to even imagine. And these are only those universes that are similar to ours, where identical copies of us live. Some universes might be completely different. They might have different constants of nature, like the strength of gravity or the speed of light. They might have things that we can't even think about. Of course, this is just another theory. There's still a big debate about it in the world. It's a fascinating idea, but there's no way for us to test it with our current technologies. These universes, even if they exist, are way beyond our reach. One of them is called M theory. It was proposed in the 90s by an awesome scientist, Edward Witten. M theory is like a super advanced version of string theory. Just like in regular string theory, it suggests that everything in the universe is made up of tiny vibrating strings. But M-theory says that these strings aren't the only things out there. There are also things called brains, short for membranes. Imagine these brains like sheets or surfaces that exist in higher dimensions. We can't see them, but they can interact with the strings in interesting ways. M-theory was basically juggling other theories trying to solve the problem in everything. It tried to unite every version of string theory into one big idea, and also combine all this with Einstein's ideas somehow. It also high-fived Stephen Hawking's ideas about black holes along the way. But even with M-theory, we're not at the finish line. No matter how hard we try, we still can't explain absolutely everything. The biggest problem is trying to unite relativity with quantum mechanics. So far, no one could do this. These were our attempts to come up with a theory of everything so far. Will we be able to derive it one day? Who knows? There are many tricky pieces still missing, but we keep learning and creating new tools to explore our world. And maybe one day, we'll finally find out the answer.